Okay. Now, let's go to example number 1. Example number 1, here we are required to do what? We need to use the remainder theorem to determine the remainder when our given function f at x is equal to 4x cubed minus 8x squared plus x plus 2, when it is divided by what? Let's start with letter A. When it is divided by x minus 1. Okay. Here, I'm going to write my solution. Number 1A. Remember, we said with the remainder theorem, our f at b must be equal to what? Must be equal to what? R for what? For remainder. For us to get the remainder theorem, we need to go the root of f at b is equal to. So in this case, where do I get this f at b? How do I determine that f at b? Or how do I determine this b? It's quite easy. I'm just going to make use of my divisor. So you take your divisor as what? X minus 1, and you equate it to what? To 0, and solve for x. We're going to have x is equal to positive 1. So in place of this b, I'm going to have my positive 1 there. So I'll be saying f at 1, remember you substitute this into your original function there, or your original polynomial. F at 1 is equal to 4 into 1 all to the power 3, there is all to the power 3, minus 8 into 1 all squared, plus, brackets are very much important, open bracket, 1, close bracket, plus 2. So 4 multiplied by 1, we say it's 4 because 1 cubed is 1, minus 8 multiplied by 1 there, 1 squared is 1, so it's 8, 4 minus 8, plus 1, plus 2. So 4, if I can add this together, 4 plus 1 plus 3 is going to be 7, minus that is going to be negative 1. So in simple terms, my f at 1 will give me what? Will give me the remainder of negative 1. Okay? Let's move to the next one, letter B. This one is more or less the same as that one, but now the only difference is that our b, or our value of b, will no longer be the same as the previous one. So still, we need to equate our divisor to 0 in order for us to obtain the value of what? Of b there. So 2x minus 1 is equal to 0. So 2x will be positive 1 transpose, divide both sides by 2. So your x is going to be 1 over 2. Now, what do I do with this 1 over 2? So I need to make sure that I substitute this 1 over 2 into the given function there, so that I can get what? My remainder. So my f at 1 over 2 is equal to 4 into 1 over 2 all to the power 3 minus 8 all to the power 1 over 2 all to the power 2, remember, plus, brackets are very much important, plus half again, plus 2. Now, let's just simplify this. You can punch this in your calculator, or you can just calculate by inspection. 4 multiplied by that, you can see 4 multiplied by 1 over 8 is going to be 1 over 2 minus 8 multiplied by 1 over 4. It's minus 2 plus half plus what? Plus 2. So as you can see here, if I can just say 2 minus 2 is going to be 0, then half plus half will give me, let's continue to this other side. Our answer is going to be half plus half. It's going to be positive 1. So in this case, if my f at x is divided by 2x minus 1, I'm going to get the remainder of positive 1. Okay. Now let's move to this other theorem, which is what is called the factor theorem. You cannot say this one is the same as the remainder theorem, remember. With this factor theorem, we can use it to apply, or it can be generally applied to factorizing and finding the roots of polynomial equations. So in simple terms, we can use this factor theorem. We are going to use this factor theorem to factorize and find the roots or the x-intercepts of our polynomial equations. According to this theorem, it states that if f at x is a polynomial such that f at b is equal to 0, then our x plus b is going to be what? It's going to be a factor of the polynomial, right? So in reverse form or conversely, we can say if our x at x plus b is a factor of the given polynomial, then it means now our f at b is 0, or our remainder of this is going to be what? It's going to be 0. Okay. In this case now, let's just look at the difference between the factor and the remainder theorem. So with the factor theorem, our remainder is strictly 0, whereas with the remainder theorem, our remainder can be any value, but the value will not be equal to what? It will not be equal to 0. Otherwise, it will lead to the factor theorem. Now, with this example 2, or in example 2, we are required to show that x minus 3 is a factor of the polynomial. How will you see that x minus 3 is a factor of this polynomial? So in this case, for us to see that this is our factor of the polynomial, let me present my answer here. For us to see that this is a factor of the polynomial, our f at b, or our remainder, should be equal to what? Should be equal to 0. Okay? Where do I get this b? How do I determine b? Straightforward. You just go to your divisor, take your divisor, and equate it to what? To 0. Therefore, your x is equal to 3. In place of b, now I have what? I have 3. So in other words, I'm looking for what? My f at 3 must be equal to what? Must be equal to 0. Now, I'm just going to substitute my 3 into the original function. So I'll say 3 all to the power 3 minus 3 all squared minus 5 into 3 minus 3. So 3 cubed is 27 minus 3 squared is 9 minus 5 times 3 is 15, and then you're going to have minus 3. Then when you simplify this whole thing, 27 minus 9 minus 15 plus that gives you 0. Therefore, if your remainder is 0, then it means you can say my x minus 3 will be a factor of the polynomial. So now you have shown that this x minus 3 is indeed a factor of the polynomial. Then you are covered with this one, right? Remember, the remainder should be equal to 0 for you to say this linear is a factor of my given polynomial function. Okay? Now, moving on to the next slide. Here, I was trying to emphasize to you the methods or the ways in which a cubic polynomial can be factorized. So for you to factorize a cubic polynomial, you need to ensure that, number one, you apply the knowledge of your factor theorem by using what? By ensuring that you get at least one factor using that. How do you determine that? Make sure that you focus on the constant of your given function. From there, you can just use your trial and error method to determine the exact factor of the polynomial. From there, you can just use any method from the list. You can use your long division, you can use your synthetic, or you can use your inspection method. Now I'm going to take you step by step on how to treat or on how to deal with each and every method here. Right? Let's do example number 3A together. Here we are required to factorize these polynomials or functions by using the long division method. How do we use the long division method? If you can just make sure that you have this portion. This is for my rough work, guys. This is for my rough work. That's where I'm going to write my proper work here. Right? It should be presentable. Now, let's look at the first equation. Our first equation in A we need to find, number one, remember we said we need to find all the possible factors of our constant term. In this case, what is our constant term here? Which one is our constant term? Our constant term is +6 or +6. So what are the factors of this +6? Remember, a factor from our grade 9, we know that a factor is a number that can divide exactly into another number without leaving any remainder. So in here, a number that can divide into +6 is positive, plus or minus 1. We have plus or minus 2. We have plus or minus 3 can divide into this. And then you also have a plus or minus 6. Then what do I do with these factors? Simple. I'm going to use the trial and error method. This is how I'm going to use my trial and error method to test as to whether which one gives me the remainder of 0. And then where you get the remainder of 0, it means that particular value will serve as your factor of the polynomial. Now, let's try this one, the positive one. F at 1 is equal to 1 cubed minus 4 into 1 squared plus 1, brackets are very important, plus 6. Therefore, what is your F at 1? You're going to have 1 minus 1 cubed is 1, minus 4, plus 6, or plus 1, plus 6. Then when you simplify this, you're going to get what? Negative 4 plus 2 is negative 2 plus 6 is going to be positive 4. What does that imply? This simply means that our x, look at the sign there. Our sign here is positive, so it means our x minus 1 is not a factor of the polynomial. Why? Because our remainder is 4, not 0. So what do we do next? We need to try the next factor. If we failed with 1, now we need to try with negative 1. So how do you do that? Simple. You substitute your x now with negative 1. Just say negative f at negative 1 is equal to negative 1 cubed minus 4 into negative 1 squared. Then continue from this to this side. I don't have enough space. And then we can have negative 1 plus negative 1, right? From your original. Make sure that you substitute correctly. And then we have plus 6. Therefore, what is your f at negative 1? It's 1, negative 1 cubed. It's going to be negative 1 minus 4 times 1 minus 4 minus 1 plus 6. Therefore, what is your f at negative 1? Your f at negative 1 is giving you what? 0. Minus 1, minus 1, minus 1 is giving you 0. Then you can stop right there. Because now your remainder is 0, you can conclude to say, okay, therefore, to the next slide or to the next portion here, you can say, therefore, f at negative 1, since it's equal to 0, it means now x, remember, if it's negative here, your factor should be positive. So x plus 1 is a factor of the polynomial. This is what matters for now. Remember, we said we need to use our factor theorem to get at least one factor. Now we are covered with the first factor now. From here, we need to use our method, the long division method. Let me take you back to your grade 9 content. Remember, in grade 9, they will say to you, divide this number. 97 divided by maybe, they will say divide by 3, using your long division method. And then you'll say, your long division sign, remember, this portion is meant for what? You must know that this part is for your dividend. And then this one is for your divisor. And then here it's meant for what? For the quotient. And then our answer at the end, the answer that you're going to get at the end there is the remainder, right? So with your grade 9 content, which one is your dividend here? Your dividend is going to be 97. And then the number that is divided by is positive what? 3. So your 3 is going to be your divisor. So it's your divisor 3. You're simply going to say 3 into 9 goes how many times? It goes how many times? 3 times. There, you write your 3 there. 3 multiplied by 3 is going to be 9. Then what do? You subtract. 9 minus 9 is going to be 0. Even if you don't write it, won't make any difference. And then you bring down the next term. Sorry, you bring down the next term there. 97. Your next term is, it's 7. Then you can bring down your 7 there. It's 7. 3 into 7 goes how many times? 2 times. So 2 multiplied by 3 is going to be 6. You write it underneath this 6. Underneath 7 is going to be 6. Then you subtract the 2 terms together. 7 minus 6 is positive 1. So this positive 1 is your remainder. Now we are going to apply the same method, but now using the polynomials. This is quite easy. Using our polynomials. Remember your long division sign? Which one is your dividend here? Your dividend is going to be the given function there, x cubed minus, remember this is your dividend, right? So x cubed minus 4x squared plus x plus 6. Then which one is your divisor? Your divisor is the factor now. Your factor is x plus 1. So you're going to have your x plus 1 here. Now, you simply say the same procedure. X into x cubed goes how many times? Is x squared. So remember, you need to align your terms. It's x squared. X squared multiplied by x is x cubed. What do you do again? X squared again multiplied by positive 1 is positive x squared. Remember to align your terms. And then you subtract the terms. Now you subtract. When you subtract, x cubed minus x cubed is 0. Minus 4x squared minus x squared is negative 5x squared. Guys, remember to align your terms together. And then you bring down the next term, which is positive x. What do? You start the process again. To say x into minus 5x goes how many times? Negative 5. 5 multiplied by x, negative 5. It's negative what? Negative 5x, sorry. Negative 5x squared. Negative 5x squared, or negative 5x multiplied by 1 is going to be negative 5x. What do? We subtract the terms together. Minus 5x squared minus negative 5x squared is 0. X minus negative 5x is going to be positive 6x. Remember, it's x minus negative 5x. So when you multiply, this is going to be positive, right? So it's 6x. Then what do? You bring down the next term, which is positive 6. From there, you need to start the process again. The process again will be to say x again into 6x goes how many times? It's plus 6, positive 6. 6 multiplied by x is positive 6x. 6 multiplied by 1 is positive 6. What do? We subtract again. So 6 minus that is 0. That minus that is 0. Therefore, your remainder is 0. Remember here, you were required to do what? To factorize. Let's utilize this portion. You are required to factorize this. Therefore, remember, our dividing rule says our dividend is given by what? Is given by the divisor multiplied by the quotient plus the remainder, right? So our dividend, in this case, let me just make use of this D, capital letter D for dividend, and then small letter d for our divisor. So dividend is equal to divisor multiplied by q for quotient, and then plus r for remainder to save space here. I don't have enough space. In this regard, which one is my dividend? My dividend is going to be f at x, the original function there. F at x is equal to, which one is my divisor? X plus 1. My quotient, this one is your quotient here. There is your quotient. Your quotient is x squared minus 5x plus 6, right? Minus 5x plus 6. Therefore, what is your final answer on this one? You're going to have your factors as x plus 1, and then you can factorize this. Remember, this one is your quadratic expression. You are able to factorize it. So the factors of this will be x, and then the sign here is positive, so the sign is going to be positive, or negative and negative. In this case, I'm going to make use of the negative and negative, because now the middle sign is negative, so it's negative. I'll consider minus and minus. So the factors of 6, we have 6 and 1, right? 6 and 1, positive 6 and 1. We also have 3 and 2. So in this case, I'll make use of what? I'll utilize 3 and 2. So it's 3 and 2. Remember, when you multiply this x together with this negative 2, it's going to be 2x. Together with this one, negative 3x, they must give you what? The sum of these two must give you the middle term, which is negative 5x. So our factors are indeed correct. And now we are done with this letter A. Let's move to the next one. Moving to the next one. My rough work there. Guys, you can always use your calculator. Feel free to use your calculator. Now, your f at x is equal to x cubed minus 12x plus 16. Remember, we said we need to find all the possible factors of what? Of 16. We have plus or minus 1. Let me write them here. Possible factors of 16. We have plus or minus 1, plus minus 2, plus minus 4, up to, or plus minus 8. You can also write plus minus 16. Those are the possible factors of what? Of 16. But in this case, if you can look at this function or this polynomial, other terms are missing. Remember, we are saying this cubic polynomial should be in the form of what? Ax cubed plus bx squared plus cx plus d, right? But in this case, there is this other term which is missing here. The second term plus bx squared is not here. What do I do? In this case, you need to make sure that you add the missing terms to this polynomial. So it's x cubed, but you must ensure that the coefficient of that missing polynomial is what? It's 0. So it's x cubed plus 0x squared minus 12x plus 16, right? Now you need to find your f at 1 using the first factor. They use your trial and error method. F at 1, we have 1 all to the power 3. Then 0 multiplied by x squared, it will just give us 0. I'll just write plus 0 minus 12 into 1 plus 16. So I'll have 1 minus 12 plus 16. So when you simplify this all together, it's going to give you negative that. Then it's going to be 4 plus 1. It's going to be 5. So now your remainder is 5. It means x, look at the sign. If it's positive, you say x minus 1. It's not a factor. Remember, you can use your calculator to check all the other factors there. You can also test the other factors. F at negative 1. Let's make use of the calculator to save time. Your f at negative 1, you're going to substitute with your negative 1 there. Negative 1 cubed. Avoid making mistakes, please. Minus 12 into negative 1 plus 16. So your answer is positive 27. It means still x plus 1 is not a factor. Correct. Now, let's just change back to your calculator. You just change the number, -1, and utilize +2 now. You punch in +2. When you punch in a +2, you get the remainder of 0. Then you can just say f at +2 gives me 0. Therefore, it means x, look at the sign positive, I'll say x minus 2 is a factor of the polynomial. So what do? I'm done with the factor theorem. Now I must apply the method now. Any method that I can use here. My long division method. You write in the given function as it is. Remember the missing terms. You need to include in the missing terms. So x cubed plus 0x squared minus 12x plus 16. Don't forget your divisor. Your divisor is now x minus 2. Remember the division method, the long division method is quite easy. The procedure is still the same. You divide, you multiply, you subtract, and then you bring down the next term, just like that. So x into x cubed, align your terms, is x squared. X squared multiplied by x is going to be x cubed. You see, you divide, now you're going to multiply after this. X squared multiplied by -2 minus 2x. Can you see? You divide, you multiply, you subtract, you bring down the next term. So now you're going to have negative. You subtract the terms. X cubed minus x cubed. X cubed minus x cubed is going to be 0. 0x squared minus, sorry, this is 2x squared. 0x squared minus -2x squared. This is going to be what? Positive 2x squared. Then what do? You bring down the next term, which is minus 12x. Then you start the process again. X into 2x squared goes how many times? It's positive 2x. 2x multiplied by x is going to be 2x squared. 2x multiplied by -2x, negative 4x. It's going to be -4x. Then what do? You subtract the terms. 2x squared minus 2x squared is 0. Then 12x, remember it's negative. 12x minus -4x is going to be -12x plus 4x. So it's going to be negative 12 minus 4, going to be -8x. Then we bring down the next term, which is positive 16. Right? X into -8x goes how many times? So it's -8. 8 multiplied by x, or -8 multiplied by x is -8x. -8 multiplied by -2 is going to be +16. Then you subtract your terms together. -8x minus into -8x is going to be 0. 16 minus 16 is 0. Therefore, your remainder is 0. If your remainder is 0 like that, it means you can apply. You can always apply your dividing rule to say now the dividend is equal to the divisor multiplied by the quotient plus the remainder. In this case, our remainder is 0, so that won't make any difference. So our dividend is f at x is equal to, our divisor is x minus 2 multiplied by the quotient. Sorry, the quotient is x. Let me write it here. F at x is equal to x minus 2 multiplied by x squared plus 2x minus 8. Therefore, what will be the factors of the trinomial? You can use the quadratic formula, you can use your trinomial factorization, that's up to you. So we have x and x, we have minus, I'm looking at the sign, the negative sign there, it's going to be minus and plus, minus and positive. So the factors of 8, we have 8 and 1, we have also 4 and 2. So now I'm going to make use of this 4 and 2, but remember now, the bigger factor will take the sign of the middle term. In this case, the bigger factor is 4, so it's going to take the sign of the positive sign there. Since the middle term is positive 2, so it's minus, then we say minus 2. Those are the factors. But in short, you can just sum this to be x minus 2. You can write it as x minus 2 all squared multiplied by x plus 4. All right. That's all about our long division method. That's how we factorize using the long division method, okay? So now I need us to try the next method. I would like us to try the next method, which is the synthetic division method. Let's see then at the end so that we can compare. So that you can choose which method are you comfortable with at the end. Now let's go through the second or the fourth example. In our fourth example, we are required to factorize this still, but now we need to strictly use the synthetic division method. The first question there, you are given f at x is equal to negative x cubed plus 7x squared minus 15x plus 9. What did I say? I remember I said you need to start by determining or finding all the factors of the constant. In this case, our constant is positive 9. So positive 9 is going to be plus or minus 1, plus or minus 3. We have plus or minus 9. Those are the factors of what? Of our constant 9. Then what do we do from here? You use your trial and error method. Even if you don't write all your workings there, you just need to find the remainder of 0. When you get the remainder of 0, it means that particular value will serve as your factor. So now let's substitute. Our first factor there, let's substitute with negative, positive 1. Or in this case, let's start with positive 1. Positive 1 cubed. To save time, positive 1 cubed plus 7 into positive 1 squared minus 15 into positive 1 plus 9. Then here, our f at 1 gives us the remainder of 0. Therefore, we can say it means x minus 1 is a factor of the polynomial. Okay, remember guys, we are using the synthetic division method. So how do we use this method now? You're just going to draw the sign. Looking at your factor now, your factor is x minus 1. Now you need to make sure that you do what? You write the reverse of this one, the inverse of the negative sign, which is going to be what? Or you can just say, let's switch the sign from negative to be positive. Now you need to write down all the coefficients of your given function here, starting from the coefficient of a. In this case, the coefficient of a is negative 1. Write it down. The coefficient of b is 7, and then we have minus 15. Then the last one is plus 9. Now, remember I said here is positive 1. You need to bring down the first value, or your first coefficient. The value of your coefficient is negative 1. So positive 1 here multiplied by negative 1. So it simply means you're going to get what? Negative 1. You write it underneath the next value. Then what do we do? 7 plus negative 1 is going to be positive 6. And then Positive 1 multiplied by this 6 is going to be what? Positive 6. Negative 15 plus positive 6, that is going to give us what? 9. Negative 9. Negative 9, correct? Then you say positive 1 again multiplied by negative 1. That is going to be negative 9. So you say 9 plus negative 9 is 0. So this 0 serves as what? As your remainder. Remember, this is a synthetic division method. So in this case, you can apply your dividing rule to say dividend. D for dividend is equals to small letter d for divisor multiplied by the quotient plus the remainder. In this regard, which one is our dividend? Our dividend is the given function f at x. So f at x is equals to our divisor. Here is our divisor, the factor, the x minus 1. Now, remember, when you multiply a linear together with a quadratic polynomial, you get a cubic. So this quotient is in the form of a cubic. It's in a quadratic form. It's ax squared plus bx plus c. So one maybe is wondering, where do we get this a, b, and c? So this is quite easy. A is the coefficient. Negative 1 is our coefficient of a. This 6 represents our b. Then this negative 9 is our c. Then you're just going to substitute this into this quadratic expression, minus 1 into, then you say negative 1 multiplied by x. Remember, I said this negative 1 is the coefficient of what? Of this x squared. So negative 1 times that is negative x squared plus 6x minus 9. Remember, we can always take out the common factor from our next bracket. We can always take out the common factor of negative, just say multiplied by negative sign into negative times that one is x squared minus negative 6x divided by that is minus 6x, and then it's going to be plus 9. Okay. Then this can be simplified too. This can be simplified too. Remember, you can also multiply this negative this side. Negative into x minus 1. Now let's just determine the factors of the trinomial. So we have x and x. I'm looking at the sign there. The sign of the constant is positive, so it's positive. You can use positive or negative only, but I'm looking at the middle sign. The middle sign there is negative, so it means now we're going to consider minus and minus. So minus 3 together with minus 3. Okay, I hope everyone is fine with that one. Therefore, our last term or our last solution there will be equals to negative into x minus 1 multiplied by x minus 3 all to the power 2. Those are the factors of the polynomial by using the synthetic division. Okay, I hope everyone is fine with that one. Let's try the next one. The second one here. But still, let's use the synthetic division so that we familiarize ourselves with these different methods. Then at the end, you can choose any method of your choice, remember. You are not restricted to choose a long division or a synthetic whenever you feel like using the other method, either way around. Okay? 2a. Now you are given this function. Remember I said, if you are given a function like this one, where there are missing terms, you need to make sure that you add in the missing terms. So g at x is equal to, still, we don't have all the terms here. So it's x cubed. You don't have the term x squared. So we need to say plus 0x squared. You need to ensure that the coefficient of the missing term is 0. So minus 12x plus 16. Remember, from our previous slide, we already know the factors of what? Of plus 16. So remember, it's plus minus 1. I'm not going to write them again. I'm just going to write the few. Plus minus 1, plus minus 2, up to plus or minus 16. You need to make use of your calculator, guys, to save time. You don't have to write the whole statement here. So, it's 1. Oh, by the way, we did this one previously. So we already know that our f at 2, let's try it again. 12 into 2 plus 16. Oh, since we know that in this case, we don't have g, but you are given, you don't have f at x, you are given g at x. So our g at 2 gives us the remainder of what? Of 0. Therefore, it means x minus 2 is a factor of the polynomial. Since x minus 2 is a factor, going back to your synthetic division, remember to switch the sign of your factor is minus 2, so you need to write positive 2 right here. And then you need to write down the coefficients of the function. The first coefficient here is 1, then you have 0, then you also have to write negative 12, you need to also write positive 16. What do we do next? You bring down the first value there. So the first value is positive 1. Then what do we do? 1 multiplied by 2, positive 2. 0 plus 2, positive 2. Right? 2 multiplied by 2 is positive 4. Minus 12 plus 4 is going to be negative 8. 2 multiplied by negative 8 is going to be negative 16. Then what do we do? 16 plus negative 16 is 0. So since this 0 is your remainder, you must know that this 1 is the coefficient of A, 2 is the coefficient of B, and then this negative 8 is the coefficient of C on your quadratic expression. Right? Remember, in this case, dividend is equal to divisor multiplied by quotient plus the remainder. Our dividend is g at x is equal to x minus 2 is our divisor. This factor is our divisor. And then, remember, this is in the form of ax squared plus bx plus c. But there's no need to write this in the near future. And I'm just showing you the example. So x minus 2. The coefficient of a here is 1. So it's 1 multiplied by x squared. It's x squared plus 2x minus 8. Correct. Now you can determine the factors of this trinomial. You can use your trinomial factorization. You can use your long division method. We have x, and then the factors of minus, this minus sign is going to be negative and positive, right? So now we can have what? Negative and positive from there. Minus positive, that one is 8 and 1. We have 4 and 2, right? So the sign, remember the bigger value, take the sign of the middle term. So it's going to be 4 and minus 2. Therefore, we're going to have x minus 2 all squared together with x plus 4. Remember, now they are saying, moving to the next question, hence, show that g at x is equal to 0 will have how many roots? It will have 2 roots. Now, let's make it fast. We don't have time anymore. From here, remember, when they say hence, they want to say using what we have already worked out, you need to determine the values of what? 2 roots, the solutions of x. So you just say, since my g at x is equal to what? 0. Remember, this is what? Is 2, letter B. Since my g at x is equal to 0, I will have to say x minus 2. I don't have to start afresh to do the calculations because it's already there. X minus 2 and x minus 2 multiplied by x plus 4 is equal to 0. Correct? Therefore, we can have our x is equal to 2 or our x is equal to negative 4. Therefore, it means our g at x has 2 solutions indeed. All right. Okay. Because we don't have time anymore now, let's move quickly to the last example there. But now I'm going to use the other method, inspection method. Let me be fast on this one. The inspection method, example number 5, the inspection method. You are required to factorize the following polynomials by using the inspection method. So by this inspection now, I don't have to copy down this question. It's already there. You already know the factors of plus 6 is plus or minus 1. If you can just utilize this 1, substitute your factors there, 1 cubed minus 4 into 1 squared plus 1 plus 6. So you change to minus 1, minus 1, minus 1. So it means now in this case, our f at minus 1 is 0. Therefore, it means x plus 1 is a factor of the polynomial. Ax squared plus bx plus c is a factor of the polynomial. Now, let's look at this. You need to determine the coefficients of a and c by inspection. So now remember, when you multiply this x multiplied by ax squared, it will give you this term here, x cubed. So now you can know the coefficient of this x here is 1. So 1 multiplied by any number should give you this coefficient of x cubed. So 1 multiplied by 1, it will be positive 1 here. So here I have ax squared plus bx and then plus c is the constant. When I multiply this positive 1 together with c, I must be able to get which one? To get this positive 6 here, right? So 1 multiplied by positive 6 is going to be what? 1 multiplied by positive 6 is going to be what? 6, the constant of the original, right? Remember, f at x is equal to. Now, the factors will be, how do I determine this coefficient of b now? I need to say, or consider the values or the products that will give you a term with an x squared. The first one is going to be x multiplied by this. When you multiply x together with that, it's going to be bx squared. Then 1 multiplied by x squared is plus x squared. Then you equate it to the like term from the original function. They are equal to negative 4x squared. Now, common factor is x squared into b plus 1 is equal to 4x squared. Now, you just equate the bases. b plus 1 is equal to 4. Negative 4, sorry. b plus 1 is equal to negative 4. Let's write negative 4 here. Therefore, b will be negative 5. Then, in conclusion, I'll say x squared minus 5x plus 6. Therefore, you can just factorize from there. X plus 1, x and x. Then the factors there will be minus and minus 3 and 2. Those are the factors of the polynomial f at x is equal to that. Guys, I think we have reached the end of our lesson. Remember, practice makes perfect. Until we meet again next time, guys, goodbye for now.
Hi and welcome, grade 12. We are speaking to Nkosinathi Mngoni from Ekurhuleni South District. Today, we're going to be doing our maths lesson on cubic functions and graph interpretation. So, our outcomes of this topic, by the end of this lesson, you should be able to sketch graphs of cubic polynomial functions using derivation. Apply the steps of sketching the cubic functions. Graph interpretations that involves given x-intercept, turning points, stationary points, and other point, and both stationary points. So we're going to be having three cases. One is x-intercept only. 2, it's stationary point and 1 point. 3 is both stationary points. All right, let's start. In a cubic function, it's given as f of x equal to ax cubed plus bx squared plus c. also plus D. So in this topic, I know grade 12 learners, this topic is new to you, but if you can have an idea or the background knowledge of functions and also algebra, you're going to be working with that here. So this topic is so interesting because it's just an extent of parabola graph and also the algebra. Okay. 6 steps that must be included. So let's go back there. Something that you're missing. So our cubic function, it's in a form of, in a graph like this, whereby 1, we need to include the turning points. In our previous lessons, we have explained that's going to be my maximum turning point. This one would be my minimum turning point. And then we also need to show a point of inflection. Can I use P of I? And also, we know that since you're using a Cartesian plane, we're going to be having our x-intercept there. So what is new in this topic? In this topic, we're going to be having 3 x-intercept. Previously on parabola, we were having 2. Grade 10 on straight line, we were having 1. But in this topic, you're going to be only having 3 x-intercepts. Yeah, all right, that is key. And then when you can draw that due to our Cartesian plane, we'll also need to show our y-intercept. So this one is my first x-intercept, which I can call it root 1. This one can be root 2. That one can be root 3. So that is what is given here. Then, 6 points that must be included when sketching a cubic graph. 1, we said there must be x-intercepts. Those 3, y-intercept, and also stationary points. This one, stationary point, and also that stationary point. And lastly, there must be a point of inflection, which is this one, inflection. Sketching a cubic function. We need these steps. Step number 1, we need to get an x-intercept. How do we get x-intercept? We are using, again, grade 12. So we are using what we were doing in grade 11. How do we calculate x-intercept of a parabola? We're saying we're going to let f of x be equal to 0 into our f of x. It doesn't change. Same thing that we were doing last year, still applying it there. And then, when getting our x-intercept, let's remind ourselves of this. When getting our x-intercept, yes, we said we're going to let y equal to 0 or f of x equal to 0 into f of x. All right, into f of x. This means, since we are dealing with a cubic function, we will have 3 roots. If I can use that part, I will show you where it does come from, x minus root 3. You're going to be having 3 roots, so those are going to be my x-intercept. There, there, and there. Then, secondly, we need to calculate the y-intercept. How do we calculate the y-intercept? You're going to let x to be equal to 0 into our f of x. Same thing as we are doing in parabola function. So that's going to be easy. Where we see the value of x, we're going to put 0 in order for us to get our y-intercept. Thirdly, how do we get our turning points? Turning points, the other name of it, don't forget, it's our stationary point. How can we get that? Remember from our previous lesson, we said a stationary point. We said our stationary point there, the gradient is equal to 0. The gradient there is equal to 0. Why? Because of it's a horizontal line. Okay, that's why we're going to be letting our first derivative to be equal to 0. Also here, our first derivative to be equal to 0 to get those turning points. And then after, check this thing, and then substitute in the place of x. So substitute x in the place of x in our f of x. Why are we doing this thing? We are looking for the y value now. We are looking for the y value. From our roots, or from the first derivative, we're going to be getting the x, and then you substitute that x value to f of x to get the y value. Second one, the point of inflection. The point of inflection is where the graph changes its concavity. Don't forget that. It's where the graph changes its concavity. And we will get by doing what? By doing the second derivation and equate to 0. Let me explain why do we equate to 0. If I can draw the second derivative graph, it would be in the form of a straight line. It will be in the form of a straight line. And in the form of a straight line, if I can draw my, so we're going to be having our cubic function. The point of inflection, let's say, is there. When I draw the second derivative function, you will discover that the x value of the point of inflection, the same x value, become our x-intercept of the second derivative graph. So that's why we're going to be equating that to equal to 0. Therefore, after, for me to get the y value, I will take the same x value, substitute in the place of f of x function, in the place of x. So I will get the coordinates now of point of inflection. Number 5. And then let's determine the shape of the graph. That's where we need to have some little bit of explanation. In our lesson today, we'll be given something, a function like f of x is equal to 2x cubed minus 3x squared plus 4x minus 5. How can I determine the shape of the graph? So what do we need there? Without sketching the graph before, you need to first know this value of a. If the value of a is greater than 0, how does the graph behaves? If the value of a, let's say, for example, if the value of a, it was -2, or if a is less than 0, how our graph going to look like? So you must have that idea before sketching the graph. So let's get some example. So over here, I'm having some little bit of information about the value of a. So the value of a here, if you can check there, the value of a is less than 0. So it means you will see a graph in a form of like this. You will see a graph, it says f of x is equal to negative maybe 3x cubed plus 2x squared, like that. So now you can see that the value of a now, it's less than 0. What we must know then, when the value of a is less than 0, the graph will start by going down and then come up, go up, and then go down. Those signs that I've used here, negative, 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 those signs, positive, 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 negative, negative, they are explaining the average gradient at a given point. At a given point. If I can draw a tangent at this part, it will be going down. If I can draw a tangent, its gradient will be negative. If I can draw any tangent line there, its gradient will be negative. So that's why you see all these negatives there. So going to be negative, negative. But there at stationary point, don't forget, the gradient is 0. Why? Stationary point. Then, when you go to this part now, oh, my graph is going up. I see now when I can draw any tangent, I can see that the gradient of it will be positive, 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 positive. So at this part, when my graph is going up, the gradient is positive. Hence, you see the positive sign here. So it means the gradient there is positive. Then, I now see a special thing there, which is also my stationary point or my turning point. I know that my gradient would be equal to 0. So I know that there is my stationary point, it's 0. After I see that my graph is going down again. So I go down, if I can draw any tangent line, its gradient from y equal to mx plus c, its gradient will be negative, 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 negative. So that's what is being explained there. So agree with me that if the value of a is negative, we will start by seeing in a numerical order, you know, we are counting from negative infinity to positive infinity. In a numerical order, if the value of a is negative, we'll start by having a minimum turning point and followed by a maximum turning point. Simple like that. So you need to know when the value of a is negative, how would my diagram be like? If the value of a is positive, I know I'm having an idea of having a sketch of a graph like this. So this is just being explained by what you see, or I can say the coefficient of x cubed. Are we together? Right. Then, let's go to when the value of a is now positive. Let's have an example of a value of a now positive. I'm thinking of f of x to be equal to x cubed plus 2x squared plus minus x, maybe plus 5. I don't need everything here to determine the shape of the graph. Don't forget, we only need the coefficient of x squared, which is the value of a. So the value of a in this example is 1. Oh, 1 is positive. So a is greater than 0 in this scenario. How would be my graph? If the value of a is positive, my graph will start by going up, and then at a certain point, go down, and then go up. So let's check them. Those positive that you see and negative, how can you explain them? If I can draw any tangent line there, if I can draw any tangent line, do you agree with me that you will get the gradient of those tangents to be positive? And then, special thing that we see again, we see a stationary point. The gradient there is equal to 0. After this stationary point, I now see something now. My graph is now going down. My graph now is going down. The gradient there now, if I can draw any tangent line, there, any tangent line somewhere at any given point, I will see that the gradient of that tangent is negative. It's going down up until, again, a special thing where we see our turning point, stationary point. The gradient there is equal to 0. Then, after the stationary point here, I see that my graph is going up. Or when it's going up at any given point, at any given tangent point of contact, I see that the gradient is positive. It's positive. So we can make a conclusion that if the value of a is positive, my graph will start by going up, which means we can also say increasing, and also go down, which is, we can say it's decreasing. Let me write it in a way that you can able to read. We can now say my graph here is decreasing. So all this part, my graph is decreasing. And then after the stationary point, I see my graph is going up, which is increasing. All right, I was just explaining when we see the value of A to be like this, in order to have a correct graph when we are facing this question on exam. Oh. All right, let's get some examples now. Sketch the graph of f of x equal to negative x cubed plus 5x plus 8x plus 5x squared plus 8x minus 12, showing the stationary point. Oh, no. So we must remember that, okay, in this problem, I must not forget to show the stationary point, those turning points. So it means I must get those turning points for me to get marks. And also the intercept, I must also include the coordinates or the x-intercept that I see there at my graph, okay? And also I must, the point of inflection, where the graph changes its concavity there, the point of inflection. Okay, so what do we have there? We are having a function. Let me write it there to save it. We are having f of x is equal to negative x cubed plus 5x squared plus 8x minus 12. All right, let's see. Following those steps, we said for us to sketch a graph, these are things that we need to identify. Then let's check now the x-intercept. Let f of x to be equal to 0 into this f of x. Then, first step, you agree with me, that's our f of x. And then, in the place of y, or in the place of f of x, what do we put? We put 0. And then, we're now going to get some factors. You agree with me that there is a common sign there, which is negative. I took out negative there. And then, divided by -1 both sides, you'll agree with me that I'm having that answer. And then now I must get the factors. How can I factorize this thing? f of 1, if in the place of x, I substitute by 1, what do I get there? Let's check. In the place of x, what do I get there? Minus 12. So this is going to be -1 plus 5 plus 8 minus 12. I will get what here? Going to be, allow me to say -13 this side, due to the negative and the negative, due to the negative and the negative there. Here I will get also +13, +13. So I see that these two, they give me 0. So x equal to 1 is equal to 0. Okay, x equal to 1. If I transpose x that side, I see that going to be x minus 1 equal to 0. Oh, is a factor. Is a factor. So x equal to 1 is a factor. I can use this part when dealing with inspection. I can use this part when working with synthetic division. All right, I was not there, I was just explaining how do they get that factor that you see here, x minus 1. That's what you see, the x minus 1. It comes from substituting by 1 and then transpose it that on your left and then become negative. So what do you see is that I've now chosen to use a synthetic division, synthetic method. So I will put 0 here. Those 0 that you see, these 2 zeros, they are standard. So 1 plus 0 is 1. 1 times 1 is 1. That 1. And then negative 5 plus 1 is negative 4. Then you negative 4 times negative 4, negative 1 times negative 4, you see that is negative 4. Negative 8 minus negative 4 is negative 12. The same negative 12 multiply with this, you will get negative 12. So I see that I get 0 there. So this is correct. Okay, then if I continue, you will allow me to say in this value of 1, that's what you see there, negative 4 there, it's given in there. Negative 12 is also there. So I've chosen the simplest one to factorize this cubic equation. All right. Then, can I factorize further that part? Can I factorize further that part that says x squared minus 4x minus 12? Can I factorize this part? Yes. I can use the factors of 3, maybe 3 and 6, 3 and 4, or 6 and 2. Let's check. I was supposed to introduce you to other part, but let's check the simplest one. Yes, I can factorize that part. And then, so what do we have? We're having 0 is equal to x minus 1, x plus 2, and then x minus 6. Therefore, allow me to say it's going to be x equal to 1, x is equal to negative 2, and then x is equal to 6. All right, so what you're going to see here, I put them in a numerical order. So the first one, the lowest number is negative 2, the second one is 1, and then the last one is 6. So what do we get? What do we get now from this game? We now have our x-intercept there. First one is negative 2 and 0. The other one is 1 and 0. And the other one is 6 and 0. So now we do have our x-intercept. I believe that you did understand this part. I can try to use a inspection. We are having 0 is equal to x minus 1. If you prefer this method, let's check. We are having x cubed. We are having negative x, or we are having at this point. Let's try to factorize this part using this thing. At this point, we're having x cubed. X cubed divided by x. Which x? The one that you see here. What do we get as our answer here? We will get x squared. The same x squared that you see here, I will put it just right there. So I'll be having x squared there. And then we go back and say the last number, the value of d, or the value of d now here at this stage is positive, so going to be positive 12 divided by negative 1, I get negative 12. So that negative 12 I'll put here, negative 12 plus bx. I don't know b at this moment, so how can I get b? I will say negative 1 times x squared plus x times x squared. So I get what? I get negative x squared plus bx is equal to, or b is plus bx squared, which term in f of x is also having x squared, is the one that is having 5. So now, I can now say, therefore, negative 1 plus b is equal to 5. So now I see that b is equal to 5 plus 5b plus Am I right? Yes. Positive b plus 1 is equal to b plus 4. Oh no, at this point, that negative, we remember we are working at this stage. So I was supposed to say negative what? Negative 5. Okay. Negative 5 there, so negative 5 there, I get negative 4. That's the same thing that you saw there in a place of x. So that's a negative 4 that you see. So same thing. You're going to get the same answer there. All right. Let's go to our y-intercept. Let x equal to 0. So this one is simple. You just, in the place of x, you put 0. And then you get your y-intercept. And then you get your answer. Your y-intercept is 0 and negative 12. And then, how can we get our turning point? Turning point, don't forget, is our stationary point. That's where you're going to put the first derivative and then equal to 0. Look how simple it is. So then you just put there and say, in the place of the first derivative, I put 0, divide by negative 1 to come up with a positive answer. And then I factorize that part. I get those two factors. And then I get that my x value of the point of inflection, I now have the x value of which graph? Of f of x. Of f of x. Let me just use this part. I do have now the x value as negative 2 over 3. I don't know the y value. I do have now the x value as 4. I don't know the y value. Where do we get a y value? We always calculate the y value on our graph of f. No, the derivation or anyone. So allow me to say, in my graph of f, when x is equal to negative 2 over 3, my y value will be negative 14,81. When x is 4, my y value will be positive 36. That's how we get our y-intercept, our turning point, sorry. Then, I can name that as my minimum as my minimum turning point. I can name that as my maximum turning point. All right. What are we running short of? The point of inflection. We now do the second derivation. We are coming from the f of x, f prime x, the first derivative, the second derivative of x, f of f second derivative, and then I equate to 0. And then I see now I just get the x value. Let me transpose there. And then let me divide by 6 both sides. And I get the x value of my point of inflection. My point of inflection, whatever way it changes, is concavity. The x value there is 5 over 3. I don't know the y value. Where do I get the y value? Go back to the f of x. F of x, what are you saying? In the place of x, let me substitute by 5 over 3. I get that my answer, it will be somewhere there because of its positive. Remember, this is my sketch. Somewhere there on top. Then going to be 5 over 3 and 10,59. So that's what I got. I got my x-intercept, I got my y-intercept, and then let's check how it's being point of inflection. And then you agree with me that since the value of a is negative, my graph will start by going down and go up and go down. Those signs, they refer to our gradient at a given point there. So then there is our sketch there. We see that our x-intercept there that we got there, and then our turning point there, and our y-intercept, and then our point of inflection, our maximum turning point or stationary point. That's how we sketch our function. Let's get another example. Let's look at the relationship now of f of x and f prime x, f prime x. Okay. F of x is my cubic graph. But when I plot the first derivative, you can see the relationship that I now get a parabola. Then after parabola, if I plot the second function, the second derivative graph, I see that it becomes a straight line. So agree with me that that x value of the turning point, though that x value there, the same x value that we have in my point of inflection, in my turning point, the same x value there, it becomes my x-intercept of the second derivative, become my x-intercept of the first derivative. So the same x value there, it becomes the x-intercept of the x value of the x-intercept. So you can see from those broken lines that I've used at point 4 and the point negative 1,66 there, you can see there. And then when I do, if I can highlight there, you can also agree with me that that is the point of inflection. In that point of inflection, I see that how does it relate to my first derivative is the x value of the turning point there. That point of inflection is an x value of a turning point on my first derivative. Same time, the same x value becomes a x value of an x-intercept in my second derivative graph. So the relationship, that's why when we come and calculating for the point of inflection, that's why we say f prime prime x is equal to 0. Why? Because of the same x-intercept is the x value of the point of inflection. So that's a relationship that you need to know, that if I'm given only the x-intercept of the first derivative, you must know that those x values, they become your x values of the turning point. Right. Exercise 1 is given like that. Let's do it together. We're having f of x. F of x is equal to x cubed minus 4x squared minus 3x plus 18. Okay, first question. Write down the coordinates of the y-intercept. Don't forget, learners, when we calculate for a y-intercept, if you are looking for y-intercept, we let x to be equal to 0 into f of x. Then, this means going to be f of 0 in the place of x, this one. In the place of x, I'll put 0. That's what you see here. So it means I'm going to be 0 cubed minus 4, 0 squared minus 3 times 0 plus 18. So it means my y value is equal to 18. So the y-intercept, therefore the y-intercept is 0 and 18. Done. Number 1. Let's go to number 2. This one is simple number. Number 2, how can we get our coordinates of, calculate the coordinate of the x-intercept? F of x is equal to x squared minus 4x squared minus 3x plus 18. So how do we get this thing? We say, if you're looking for x-intercept, we will let f of x as being given as that, or if it was y, we say y equal to 0 into the same f of x function. So going to be 0 is equal to x cubed, going to be x cubed minus 4x squared minus 3x plus 18. So how can we get our factor? We'll use our calculator. In the place of x, substitute from -1, -2, negative, all those values, and then allow me to use -2. Let me start by -2. Minus 4, because of time, negative 2 squared minus 3 times negative 2 plus 18 if my f of x in the place of x is negative 2. Let's check. What do we get there? So is negative 2 cubed minus 4 times negative 2 squared minus 3 times negative 2 plus 18. We get 0. Oh, f of negative 2, we get 0. So getting 0, it means if x is equal to negative 2, then I transpose x is equal to x plus 2 is equal to 0. All right, is a factor. It's a factor. Then now, having x plus 2 as a factor, don't forget x plus 2 as a factor, or I can use this. I can use that x equal to negative 2. Let's go to synthetic division, synthetic method. Negative 2, let me copy all those coefficients. It's 1, minus 4, minus 3, plus 18. I put 0 there, I put 0 there. So you see that is standard. 1 plus 0 is 1, negative 2 times 1, negative 2 times negative 4 minus 2 is negative 6. Negative 2 times negative 6 is positive 12. Positive 12 and 3, negative 3 plus 12 is positive 9. And then negative 2 times 9 is negative 18. So now I see I get 0, positive 18. That. So now I'm having equal to 0, x plus 2. Where does this x plus 2 come from? From transposing that negative 2x that side. And then I'll be having x squared for this one x, negative 6x plus 9. So I can now continue and factorize this thing to be what? To be x plus 2. Here I can choose 3 times 3. It's 9. 3 plus 3 can be 6. So negative 3, negative 3. So going to be x and x there. So my x-intercept in this function is x equal to negative 2, x equal to 3, x equal to 3. When I have equal x-intercept, how can I explain this thing? If I'm having equal x value of x-intercept, it means I'm having a turning point there at x equal to 3. It can be going down. It can be going down like that. But there, I now have my turning point. So let's continue. Second question, determine the turning point. Already remember from previous, I said if there are two roots or two x-intercepts being the same, my turning point will be there. So the first turning point I do have there. So let's calculate the other turning point again. Number 3. You know that you have to first do the first derivative, which is going to be 3x squared minus 8x minus 3. Then equate to 0. Why equating to 0? Those are the stationary points. So don't forget, guys, to always equate that to 0 if you're looking for stationary point. How can I factorize this thing? I can say 3x squared, 3x times x. This side, I'm targeting to get the negative 3, 3x squared, or 3x times x. This side can be 3 times 1. Maybe I can get the negative 8x. Let me see, what do I get? I'm trying to factorize here. I have 9x, I have x. For me to get the negative 8, you bigger now must take negative. So can I put positive u, small boy? Yes. So here gonna be positive negative there. So my factors, now, my factors that cause, you will know what term is that, then I'm having 3x plus 1 and x minus 3. Therefore, or let me not raise that. I'm having my x-intercept, or I'm having my x values as x equal to, let's say 3 there, equal to -1. X is equal to -1/3. That one is x. This one gonna be x equal to 3. So I'm having two x values. This one is the one that we said, oh, if you're having two roots being equal, the turning point, it's there. The only thing that we can calculate when x is -1/3. When x is equal to -1/3. So if we substitute them, when x is equal to -1/3, what am I looking here? I'm looking for the x, the y value. So 4 times -1/3 squared minus 3 times -1/3 plus 18. So going back there, what do we have? We're going to be having -1/3 cube minus 4 times -1/3 squared minus 3 times -1/3 plus 18 I get the y value if x is -1/3 as 500/27 in decimal. Approximately that answer is 18,52. All right. So in the next turning point when x is -1/3, my y value is 18,52. That's how we get the turning point. Where is the other turning point? Is the one that we have identified to be the same as the x-intercept. So that turning point, the second turning point was 3 and 0. Yes. Then, let's move now. Sketch the graph now. Sketch the graph. Can I use this x-axis? You will allow me, if I was having time, to plot all those turning points, all those x-intercept, allow me to give it to you like this. So where you see all those x-intercept, you agree with me that since we're having two equal x-intercept, that's where our turning point is. So this will become easy when you get all those points. This is my point of inflection, my y-intercept, turning point, x-intercept, as well as also turning point. So this question, when sketching the graph, this becomes easy. All right, let's go quickly to the graph interpretations. There are 3 cases that are usually being given when determining the equation of a cubic. This one's going to be easy. 1, you must be given x-intercept. 2, you must be given stationary points. 3, you must be given a derivative graph. Okay, let's check now. Case number 1. When given the x-intercept, what do we do there? We use this form of equation. From grade 11, when calculating determining the equation of this parabola graph, we're saying y is equal to ax minus root 1, x minus root 2. Why are you ending there? Why are we ending on the root 2? We're having 2x-intercept. That's why we ended here. But now, as we are working with cubic, we now go to x minus x cubed. Okay, simple like that. Let's check this example. Determine the equation of g of x ax squared, ax cubed plus bx plus cx plus d, if passes through the points of -2 and 0, you must know already that is my x-intercept. -1 and 0 is also my x-intercept. 4 and 0 is also my x-intercept. And this part. This one is given like it also passes through this other point like that. But this is not an x-intercept. This one is our y-intercept. Okay, how do we solve that solution? We do have this part. And then in the place of R1, root 1, we're going to put -2. In the place of root 2, we're going to put -1, as you see there, and then as you see there. So then, and then we get, if you remove the bracket a little bit, we get those 3 factors. How can I get the value of A? Value of A in red, how can I get that? I need to get any given point in my function. Is where am I given another x value or another coordinate? Already we were given those roots. Those roots, can I use this diagram? I'm given there, I'm given this one, I'm given this one. Is there any point given? In this scenario, yes, there's somewhere given as 0 and let's say as 0. Maybe at this point, we are given as 0 and 8 or -8. So it means to be down there, to be down there, to be down there. Let me give you a correct diagram. So we are given those 2 roots, there and there and there. And also you are given that point. So you can have something, maybe it was passing like this. Yes. Okay. Let's follow the method. So I can get A by substituting by at any point. So I see that at 0 and -8. Then I substitute there in the place of A. And then I get that my A will be equal to 1. I go back. You go back now to this point there. And then substitute in the place of A as 1. And then try to remove the bracket carefully. Remove those brackets, add like terms, and then that you get our equation of g of x, like that. Yes. Let's move quickly in this example. Maybe it will be nice for you to do it quickly. Let's check. Determine the equation, sorry about that, of the graph below as x-intercept -2 and -3 and 0, 2 and 0, and passes through 3 and -6. So I see there I'm having 3 roots here. So I can say root 1 is equal to -3. The other one, root 2, is equal to 2. And also root 3 is equal to 2. So y equal to a, x minus r1, x minus root 2, x minus root 3. So going to be y equal to a, x minus -3, and also x minus -2. There's no negative sign there, and also x minus 2 here. So what do we have? We're going to be y equal to a, x plus 3. Here going to be a minus 2. I can say all squared, or I can just say, repeat it again, like that. At which point, let's copy that method previously. At which point, or at 3 and -6. My x value, therefore my y value is -6. My a is still unknown. My y value is 3 plus 3. Let's save time. -6 is equal to a plus 3 here. It's 6. It's 6. Here it's 3 minus 1, minus 2, sorry. My answer is 1. Also, 3 minus 2, my answer is also 1. So I'm having -6 is equal to 6a. So you'll agree with me that the value of a, is equal to -1. Yes, it's -1 because it's going down and go up and then go down. I go back and substitute where I say y is equal to a, x plus 3 x minus 2, x minus 2. Let me just be quick. So here I will put negative 1. Y is equal to negative x plus 3. X squared minus 4x plus 4. And then y is equal to negative x cubed minus 4x squared plus 4. And then I get positive 3x squared minus 12x plus 4. So I have written it in terms of, to be easy for me to just get like terms. You don't have a like term, you just x cubed. You do have a like term, I will get negative x. You have a like term. Oh, sorry, there is also x there. Also x there. So here I'll get negative 8. I'll get negative 8x, then plus 4. Let me check. There's no mistake that I did. I multiplied these two, I get that. This 2, get that. This 2, I get that. That, I get this. I get that negative, and I get positive. Yeah, I think I'm correct. So removing the sign, y is equal to negative x cubed minus plus x squared minus 8x, or plus 8x minus, oh, there's a mistake here. The here is 12. It's 12 plus 12 plus 12. So here it's also plus 12 plus 12. So it's going to be minus 12. Let's see. Yes, 12 there. So that is my, I can just save time to call that my g of x. All right, my g of x. Next slide. Let's hurry up now. Given two stationary points, I'll just look at the examples. Here we're given now stationary points there, those turning points. How do you do that? You first do the first derivation, and then at this point, the gradient is that equal to 0, where x is equal to negative 1. So don't forget, stationary point, I always equate it to 0. So what do you see there? I have unknown a, b, c. I have unknown b, c, d. In this question, before going further, as you see there, it says f of x is equal to x cubed. Already we are given the value of a to be equal to 1. So there, the value of a is equal to 1. All right. So the first derivation, that's what you see there. At x equal to negative 1, let me substitute by x equal to negative 1. I get this unknown b and also unknown c. Don't forget, you only put those x values whereby are they for the stationary point or turning point, not any x value there. And then I'm now having equation 1. So at b, remember b is also a stationary point, which is a turning point. So I can say now my x value is 3. So let me see when I put in the place of x is equal to c, and then you get your answer like that. You do the equation of you equate two equations. Why two equations? Because of they're both having the same subject of the formula. Is c is equal to in equation 1 is also c equal to in equation 2. So I can just equate the two and have what we see here. Equation 1 is equal to equation 2, and then c is equal to c. In the place of c, I substitute those equations. I'm looking for the value of b here, and then I get that b is equal to negative 3. Okay, if b is equal to negative 3, how can I get c? I can choose any equation. I'm choosing equation 1 because it's a little bit simpler. It's not having those big numbers like 6 and 27. So let me just take advantage of of equation 1. So I see that when I get my value of c, it gives me negative 9. So my equation now, the value of A was 1, yes. How can I get D? That negative 3 is for B, negative 9 is for C. How can I get D? D is not having X. So I can say D can be something like a y-intercept, or I can use equate to 0 if I was given the y-intercept. But now, am I given any point here? Yes. Those negative 5 and negative 37, do you remember we didn't use anything about it? Those that negative 5 and also negative 37, we didn't use anything about it. So those coordinates, we're going to use them to get D. Check there. The value of D, substitute coordinate A into f of x. So in the place of y is negative 5, in the place of x is negative 1. I substitute there, I get my D. I get my D as, negative 10. So my full equation now is f of x equal to x cubed minus 3x squared minus 9x minus 10. All right, let's just keep that. Given derivative graphs, we're going to just look at the example. All right, so that's where now we're given, not f of x, you're now given this graph now. You'll see in an exam with this sign that says this is a f prime, not just f. So how do you solve that? You do what? Let's check the examples. In a diagram, the graph y is equal to f prime x. They're just telling you that is in a first derivative form. All right, let's check now. Determine the equation of the f prime x. How can you determine f prime x? F prime x we have seen as being a parabola. Okay, if it's a parabola, it means that's where you can go and say y is equal to a x minus root 1, x minus root 2 only. Why? Because of it's in a form of a parabola. Then, remember we have two x-intercepts there, so I can substitute them there. And then those coordinates being given in this example, those coordinates, you can name this coordinate as 1 and 0, and also that one can be 0 and 12. In interpretation, it's an x value with its average gradient in graph of f. So it's not x and y, but it's x and a gradient. So let's quickly, I was trying to explain to you why am I substituting in the place of f prime x with 12. Now, this 12 that you see is the average gradient when x is equal to 0. Yes. Then, quickly, a, it's 6. Then the f prime x is given like that. And then the first derivative graph is f of x, f prime x equal to 6x squared minus 6 negative minus 18x plus 12. Then the last part, f of x, how can you get f of x? We were told that f of x is in the form of ax cubed plus bx squared plus cx. In this scenario, allow me to say, they have left out d. So it means if d is left out, you must know that it's 0. So quickly, let's check. So first derivative, standard point. We got that previous question. And then let us equate the two. 6x or 3a is equal to 6. That's what you see there. All the red part is 12b equal to 18, negative 18. And then c is always going to be 12. So the value of a in this simplest method, the value of a is 2, the value of b is negative 9, the c is negative 12. So hence we get our f of x to be equal to 2x cubed minus 9x squared plus 12x. Then we get our function like that. Here that's our diagram in idea that, oh, we're going to be having something like this. And then I would like to thank this opportunity for you, my learner, to give me this to work with me in this lesson. I hope it was beneficial to you. I hope all the best. You practice, and thank you. Thank you.
Welcome. Welcome to the first of the geography virtual lessons. I am Peter Franken. I teach geography at Pretoria Boys High School, and I'd like to tell you how passionate we are about our subject. And geography is a subject that I always say to myself and my classes with this statement: if you don't know where you are, how can you know who you are? So as much as your other subjects like mathematics and science and English and Afrikaans, I think geography is the, as I can put it, the mother of all subjects. The topic that I'm going to speak to you about this morning is rural settlements. It forms part of your exam detailing question 3 from the final exam, and that section is divided into 2. One being rural settlements, which I'll be doing with you today, and then the other urban settlements. If we advance to the first concept that we would like to look at, the definition of settlement geography. The key thing here, you would see I've underlined 2 words here. The act of settling, I will show it to you here, that word there, the act of settling, and then the place. Why this is important is particularly for those of you who are looking to go into careers such as town and regional planning, architecture. All of these have a very, very definite plan and a purpose in terms of geography. So it's not just the content, but it is the understanding of why people moved somewhere, why they chose to settle down. And in the settling down process, I'd like you to think of it much like a bottle of water in which you put some sand in that bottle of water, and then as the sand slowly sinks to the bottom, that is a settling process. So settlement is a process and a place. 2 very, very important definitions here. The one is the term site, and this particular site factor is the reason why people settle somewhere. The key word. The key word here is this word here, physical. It's the decision, the choice people make to live somewhere. It is absolutely important. I will be going through the 3 main points of site, namely water, flat land, fertile ground, and high ground for security reasons. If you look here, water is seen as a site factor, and on these 3 particular pictures at the top here is a traditional water fountain, a tap, and people would often have chosen to live near a water source. In this picture on the top right-hand side of the slide is a river, and for those of you living in some of the more rural areas of South Africa, you will often find towns that from their name you can pick up the reason, the site reason that they had for settling there. So an example like Nelspruit, from the Afrikaans spruit, the first people that lived in that area or any other area, water is an essential part. If you have to look at how water is a source of life, that would be the prime reason for deciding to live somewhere. The second reason, the 3 pictures show here flat land. Now, this picture here is a picture of a beef farm in South Africa. Here is a maize farm in the Free State and a maize farm in the Northwest Province. All 3 of them the reason, and I come back to the reason idea, the reason for them deciding to stop, put down their roots, build a farmhouse, and live there is a flat land. Now, I think you need to tell yourself why flat land is important. And this basically comes down to what makes a farm successful. And if it's flat, the one thing that you need to look at is it makes farming easier. What I mean by easier, if you have technology, if you have implements, you wouldn't want to plow up and down a gradient or a slope. You would want to make it as easy as possible. That is why after water, relief is probably the second most important factor in deciding where you should settle. The third reason is the word fertile. Fertile is a difficult word. Even in trying to find a good image for you to understand that, my understanding of fertile is it's good land to grow in. So this picture here showing the plant just sprouting out of the ground, you can get infertile land, which is the opposite of fertile. So here you might find on the left-hand side, that's fertile land shown by those plowed fields. And on the right-hand side, you would find infertile. Although it looks green, it's not suitable for farming. So where would the farmer choose to live? Probably on the left-hand side of the photograph. The next factor is a really, really interesting factor. If I can show you these two pictures, this particular slide here is taken in Israel. And in Israel, there is a place called Masada. It has a bit of a myth and a legend about it, but what I'd like you to look at is, say, from a geomorphology point of view, can you recognize this particular outcrop of land here would either be a mesa or a butte? And then here in this Indian example here on this second photograph, these people, not today, but way back in time, have chosen to live there because of security reasons. So they chose to live at the top. They chose to live at the top so that they could defend themselves against any intruders. Maybe not today, but in the past, it was one of those original reasons why people decided to settle somewhere. So to recap, you have a site reason. It's a decision that you made based on the four basic principles: water, flat land, fertile land, and a security reason. There are many others, but initially what you would be expected to do is to recognize that that is the choice, the reason why people decided to make or build a house somewhere, to settle down. The second definition, the situation of a settlement. This one, wow. If we can master this one, I would really, really be happy. In my 35 years of teaching, it's the one definition that we've struggled with. Key word here is the following in the second sentence. It talks about position and it talks about the relation. So if we talk about the situation of a settlement, there are two things we need to look at. And if we have a look at the example that I want to use here, I've taken the map of Gauteng. And in Gauteng, here we are here recording at the SABC studios in Johannesburg. I come from Pretoria, which is a little bit north in that Gauteng province. And to describe the situation of Johannesburg, if you look at the notes here, this word here, relative, it's a very, very difficult word. Relative is not your uncle or your aunt. Relative is a comparison. You compare one place to another. So let's have a look at Johannesburg's situation. Now, we do it in two ways, two really important ways. One, we compare it to other places on the map. And we use things like words like north or south, central. Those are all terms which tell us about the situation of a particular area. So Johannesburg, if we look at Johannesburg here, it has what kind of situation? So if north is at the top of the map here, south is at the bottom, let me get my west and east right. West is there, east is there. Johannesburg is in the southwest of Gauteng. Is it centrally situated? No. Midrand might be centrally situated. Pretoria, on the other hand, here up in the north, it is in the north of Gauteng. So that is a word we can use to describe the situation, not the physical, not water, not mining. It's just a description of one place compared to another. When you look at the second part of situation, then you take into account any transport links. So in your exam, be very careful. When describing site and situation, the situation is only north, south, east, or west, and then transport. So if you go back to the slide and you have a look at Johannesburg and Johannesburg's links, Johannesburg is linked by N1 north-south. It's linked by an N2. It's linked by numerous roads. So it has a very, very good situation. Does Pretoria have a lesser of a situation? I would say yes, because we have not forgotten, but what is the other way which makes Johannesburg's situation so good is that it has an international airport. OR Tambo Airport, it connects Johannesburg to how many places across the world? Thousands. So its situation is excellent. Some places that do not have good transport links have a bad situation. Those who are located on the outskirts of an area do not have a good situation. So to recap, the first two decisions, the first two principles that you have to grasp is the term site, which is a physical reason, and then the term situation is a comparison between the place you're looking at and how it fits into the wider scenario. So that's the first two parts of settlement and the understanding of settlement. We're going to have a quick look at an exercise to illustrate and to just see if you can work that one out. On our diagram, we have 4 places to choose from. I will circle them for you. There's place A, place B, place C, and place D. Question at the top says, advantage, disadvantage of living at those 4 places. It is an exam type question. It can be a paragraph question. It can be a 4 times 2 equals 8 question, where question 3 of your final paper. To answer this question, I will do it on the screen here for you. And a little bit of a tip. If you are stuck with answering a question in the exam, the most obvious thing is don't panic. Don't panic. This is a golden rule that I have used with the boys in my school and with personal experience. 2 things. Start off with starting with what do you know your own knowledge. Now, don't go and say, I know nothing. Don't do that. Just have a look at the picture. What do you know from the picture? Well, first of all, it tells you where hard rock is. Will that rock be fertile or infertile? Probably not. Would you want to live there? No. This kind of rock here might be a bit difficult, shale, but it tells you it weathers to form soil. So if we look at that one, would you like to stay there? Yeah, that for me, personally, might be a good place to be. Some more fertile soil, the word alluvium. If we want to do a little bit of gemorphology revision, alluvium is a word to describe the sand that is carried by a river. Here's some forests we can use. Here's a track, and just to give you a heads up here, the track is a situation choice. Why not site? Because it refers to a transport route, not something physical. Then if you overlook, you possibly might overlook here in the bottom left-hand corner of the picture and right-hand corner of the picture are 2 lines of latitude. So what? They have a very important part to play, because if you go back to your microclimate, you will know that north-facing slopes in the southern hemisphere are warmer than south-facing slopes. So is this a settlement lesson? Yes, it is. But geography allows you to incorporate everything, to have a fully fledged understanding. And I think why our subject is so important at university, it relies on the scientific process of seeking answers. The why is it there? Where is it? What is it? And when you start with your own knowledge, if that still doesn't help you, this sounds like a contradiction. Ask another question to answer your question. Seems like a paradox? Seems like something, no, can't ask another question. A question deserves an answer. But if you don't have the answer, you will then now say, what do these 2 lines of latitude tell me? You will see that the one is further south, and that gives an indication of north-facing and south-facing. So the advantages and the disadvantages you would look at, I'll go through some of them with you. Place number A, is it good? I think it would be really good because there's fertile soil. But on the other hand, what's so bad in living at the bottom of a valley? From your microclimate, where do frost pockets form? Where do katabatic winds blow? They blow at nighttime in winter down the sides of the valley. So place A has got some positives, place A has got some negatives. Place B is, let me just check here, is facing south. So from a microclimatology point of view, not very good. Place B, however, is far from the floodplain. That's not bad. You don't want your house washed away. You want water, but you don't want your crops flooded. Not a bad thing if you want to choose where to build your farmhouse. Place C here, that is north-facing. Not a bad place. You want warmth in summer, but exposed right at the top of that particular hill. Place D, on the other hand, good things about place D. Let's just indicate place D for you, that one there. It's not close to the river. It's got some fertile soil, but it could be prone to flooding. So what's the answer? The answer is your justification of what you've looked at. This is geography. You take the evidence from the diagram. You look at it. You critically analyze it. You say to yourself, like a hypothesis that you're doing for your SBA, the project that you're busy doing and have to hand in, I suppose, once you're back at school. There are hypotheses, so we can hypothesize, and we just need the proof. That is the important thing here. So what is my choice? There's no personal choice of preference here. I probably would go for place D. There are advantages and disadvantages, but I think the advantages would outweigh the disadvantages. What is the situation one year? If I can just finish here. This dirt track that we see running along here, which one of these towns have the best situation? I pause there deliberately. It's not its site. Which one is the best situation? Place A is on a track. Place A, you can walk to the closest village. And then the second thing, place A is in the bottom of the map, the southern part of the map. Place B is in the western part. D is in the northeastern part. So those are situation terms. Careful, careful. I cannot emphasize it enough that you make the differentiation between the two. Really, really careful on that one. There are some other factors, just to go through them, just to show you a couple of other reasons for that. On the picture here, there are two pictures. The one on the left-hand side here, I'll just mark it for you. That is headgear of a platinum mine in the Northwest Province. That platinum mine attracted people to choose to live there or to start the economic factors for starting up because of gold. So gold is a physical reason for attracting people. Even if there's not enough water, even if there's not enough flat land or fertile land, here the primary activity is mining. And mining is, gold is an attraction. The left-hand side picture, hopefully one of you one day might get there. And to those of you in Mpumalanga, if you haven't visited Pilgrim's Rest, which is the picture on the right-hand side, this is the old mining village that has been set up. It's not mining gold anymore, but it has now become a tourist attraction. But from a site point of view, the reason people move to Pilgrim's Rest, it's quite tricky. If you've driven there, there's a very, very narrow pass to get in it from Graskop and from Sabi, but it is the attraction of gold. So it's another physical reason for choosing to live somewhere. Any guesses for this particular place? Let's go with what we know. This is a harbor. Which harbor? I'll give you some more clues here. It's the busiest harbor in Africa. Yes, we can also get some accolades. It's not just the Americans who have the biggest and the best. The Nigerians might have Lagos, but this is good old Durban in KwaZulu-Natal. It is a harbor that attracted people here. Very, very nice picture. The harbor entrance is here. It has very good flat area for loading or quaysides for ships to disembark. So the choice for choosing Durban, not the Golden Sands beach, not Ushaka World, because it's not there yet. But the most important choice is where do we harbor, where do we overnight, where do we exchange, where does international trade start? If you look at the picture, if I can just do a little bit of geomorphology with you at the same time, can you see evidence on this photograph of why Durban might struggle as a harbor? I'll give you a bit of a heads up. These places that I'm marking with X, those are sandbanks. So those sandbanks, can you see they show up lighter on your screen? Those are collections of sand that is being carried down by this river. Now, why is that bad for a harbor? It makes it shallow. And shallow harbors are not good for shipping, particularly the ships that are now plying our seas, they have a displacement. Displacement is a word for how deep they sink into the water. And Durban, although it's the busiest, it also has some of its problems. But another physical site another physical choice for that particular settlement. Interesting one, the next slide. Where is this following one? Chinatown, top left. Chinatown, this is the Chinatown in Cape Town, okay? And bottom one here is a spaza dealer, a general dealer, a Somali family that have put up a general store in Soweto, in Johannesburg. Why did they choose that? Why do people, when they move, why do they choose people with the same customs, the same language, the same religion? Not because they feel better or they feel superior or they don't like you. There is just some kind of comfort in having in a strange environment, often a hostile environment, where everyone who speaks the same language, you can converse. So a choice, a sighting choice, although not a physical reason, this one, you'll find this across the world. In New York, there's a Chinatown. In New York, there's a Little Italy. And then a place that I've visited in Singapore, it's actually become quite a tourist attraction. In Singapore, the people who have left India have set up a pocket, an area where their businesses are thriving. The Indians in Singapore live together, and now there are tours to this particular spot. So the choice is a custom, a religion, somewhere where people feel comfortable. Okay, so not just a physical choice, not just a situational choice, but there are other choices in which you can make to settle somewhere. And then really close to home, something that is very dear to my heart. I don't know if you know where this picture is. This picture is taken down in the Western Cape. On the right-hand side, here, is an area designated according to the apartheid system where only people of color, black people, colored people, Indian people, were meant to live. Did they have a choice? Not at all. Do they still have a choice? I would put it to you, no. I think in the 20 years that we've had since our 1994 elections, I think those choices, economic choices, have become even harder. And here, the people on this side here, where I've put the X, there's no choice here. And then here, on this side here, on this side of the picture, look at the unused land. And there are many pictures from Cape Town where you would find a settlement in Hout Bay, a settlement that reaches up to near Constantia, that kind of housing, and then have a look how broad and open it is on the right-hand side. So political decisions, racial decisions, our history, particularly in South African settlements, we have a long way to go to try and fix this. But looking for a reason why they settled here, was it their choice? If you look at the people of District 6, did they have a choice to move to Mitchell's Plain? No. Luckily, in some ways, this is being changed, but in my mind, I think that's far too slow. And a point that would be raised, I think, in one or two of our other topics when we get to other parts of settlement geography. Point number 2. So if the first section is we looked at site and situation, next one we're going to decide, is this a rural or an urban settlement? Here, this word here, that word there. I'm very cautious when I go through this here. In the text at the bottom, you will see that the textbooks, the professors, the learned people will differentiate between these two types of settlement based on an economic activity. So that economic activity here for rural is primary. And just to do a little bit of EMS or some economic terms for you, primary means, let's put it down for you here, a primary activity would be farming, fishing, forestry, and mining. Those are the 4 factors which classify primary activities. So if you're a farmer, if you're a fisherman, a forester, or you work in a mine, your settlement, your home, is classified as a rural area. In an urban area, you'll see these secondary, tertiary, and quaternary activities here. A very brief example for you there would be the following. Secondary is a manufacturing. Tertiary is a service industry. And quaternary is a seriously new definition, and it has to do with research. Please don't do the following. I have had lessons where I start off and I say, give me an example of a rural area. And the boys put up their hand and they go, Soweto, Mamelodi, Atteridgeville, Soshanguve. No, the word rural is not a derogatory term. It is not a swear word. It simply means a different way of life based on an economic activity. Across the world, there is great conflict between people living in urban and rural settlements. It's an issue that might even lead to social and economic class issues. But for the purposes of the definition, please stick to those points. Primary is farming, fishing, forestry, and mining, and urban is secondary, tertiary, and quaternary. Just to wrap up, just to quickly show you where I need to be, would be my next slide. I need to just advance that next slide, which I'm not sure where to advance that next slide, but I need to show you a picture of some rural and urban activities just to finish off the section. Just a method. How do we classify rural settlements? We work on pattern, we work on size, and we work on function. We'll get to those points a bit later. You can classify these according to size. In the next lesson, I'm going to start off with here at the bottom and show you how to classify people in terms of, not people, apologize, settlements in terms of their size. And here's a couple of pictures on a rural settlement. Left-hand side, province, Limpopo. Look familiar? Yes, to those of us who live here in the northern provinces. This is a rural settlement. Even though there are houses here, I think the majority of people either are unemployed or are struggling, but they are mainly involved in either farming for themselves, something called subsistence farming. Here on the right-hand side, the picture here is an American farm, a farm in the Midwest. It's commercial farming, but still a rural settlement. Here's my rural village in the Limpopo province. This is on the way to the Kruger National Park, just before Hoedspruit as you drive through the Abel Erasmus Pass. And looking at it from the top, yes, it has an urban function. Here's a school, and we can go into our map work to see how we identify that school. But the majority of people living in this particular settlement does farming or is involved in farming. And then the last slide here, this is the heart of South Africa. This is Johannesburg. This is the studios where we are recording these lessons for you. And urban settlements, very, very different. Not only in terms of the size of the building, this particular building here you'll see, and the tower, we're going to, in the urban settlement lessons, we're going to describe them to you, look at their land uses, but urban settlements, very, very different. I hope you have enjoyed the lesson. I hope you have taken into account the important things about site and situation. And then the second definition, how do we differentiate between rural and urban? Thank you very much. It was a great pleasure, and we hope to see you again. The difference between rural and urban are best summed up by the following two definitions that are often asked in the exam. So let's have a look at them. There are three things. One is a size issue. So in rural, we're talking about small populations, primary activities, and then this word here, unifunctional. Don't be too scared by the word itself. Uni stands for one, and the function of a settlement is the purpose of that settlement. Purpose, what is it there for? Why is it built? In terms of urban settlements, again, have a look at the small compared to the large. Have a look at the function or economic activities, those three that I mentioned earlier. And then here's the word multifunctional. Multifunctional, the word multi means many, many functions. And I think the majority of us, particularly in the Gauteng province, are in urban areas, and we are used to many, many functions, many of them varied and sometimes very highly specialized. So that's the difference between rural and urban. Three things: size, function, those two, and then the type of economic activities, either multifunctional or one function. Just to recap, there we go, the sizes, the economic activity, the services, and then point number 4, the different land uses. That would be done in the next lesson, and we would look at that in more detail. But for the purposes of now, size, function, and then either multi or unifunctional. Right, if you get to the next and the last part of our work is to look at classifying settlements according to size. Just not a warning, I suppose, but this classification system is based on European examples, and often they are quite difficult to pick up in countries in the New World. So here in this beautiful picture of Ireland, you will see in the center of these green fields a isolated farmstead. The word farmstead I'll explain to you now, but this is a picture that some of us might want to go back to. Or some of us are saying, no, we like the urban city life. But this is an example of the smallest and least complex of our settlements. What I would like you to have a look at here, please don't get confused between farmhouse, but this word stead or steed, its actual definition is it's the farmhouse, so the X is the house, but it includes any kind of storage facilities. Here on the bottom right-hand picture, there's the farmhouse. This might be a storage facility for his tractors. That might be his chickens and pigs that he keeps. So the settlement, just watch carefully now, it's the smallest. It's involved with primary activities. This is a farmer. Here is another farmstead. Here he's cultivated lands. So this is the smallest in size, but still involved in primary activities. When you go up the ladder, this next description is I don't know if I can call foreign a strange word, But Hamlet, please don't confuse this with the Shakespeare drama that you are, I think, possibly doing in English. Hamlet is some Danish prince in Europe, but the description for a Hamlet, one step up and a little bit more complicated. So the definition talks about a grouping. So let's have a look in this grouping. Here's one house, one farmstead. There's a second one. There's a third farmstead. Here, one farmstead, second farmstead. Here, one farmstead, a second one. And they're not isolated. They're closer to each other. So we're not classifying rural or urban now. These are rural. We're not classifying site or situation. We are classifying according to size. Hamlet, second biggest, and a little bit more complex than the isolated farmstead. Number 3. Number 3 would be a village. Wait, sorry about that. I went a bit too far. Let's take you back. A village, beautiful picture. Where? Eastern Cape. This is a traditional Xhosa village. And have a look now. Is there one house? No. Are there 2 or 3? No. There are 1, 2, 3, 4. I'm not going to carry on counting them. But this is the third biggest in terms of size of a settlement. Not urban, still rural. And they're just denser. This word denser means closer. Just a little bit closer to each other. You'll see this is called a town, and I've written urban in brackets there because now we are involved in secondary, tertiary, and possibly quaternary activities, although I don't think so. So this town, which comes from Ireland in Europe, shows you the houses are closer, you find vehicles, you find roads, and you get secondary and tertiary activities being involved there. Next step up, number 5. A city, large urban area. Guess which city? I found this one because it's topical. This is the central business district of a city called Wuhan in China. I think it's become infamous for the outbreak or the center or the supposed start of the COVID-19 virus. But here is Wuhan, very, very big, much bigger than the village or even the town. Does it get bigger? It does get bigger. So number 6, this is a conurbation. Here, in terms of the conurbation, to try and understand this one, the word con, if you just add continuous and you take the last part of the word urban, they make up the word conurbation. These are urban settlements that have started joining. In the picture, here's one on the right-hand side, the red one, and here's one on the left-hand side. That word there, coalescence, sure, is just a rather large word for combining. The cities are now becoming so big that they are joining up. They're bigger than one city. It's 2 cities joining up, and we'll actually discuss in our next lesson where that is actually happening in South Africa. To use Gauteng as a province, just very briefly, I don't want to impinge on the people doing urban settlements, but to show you, here is the Gauteng province in this particular map. What are these circles? They are centers, urban centers that are growing and growing and joining up. So if you take it from north to south, you're going from Hammanskraal up in the north, and you are moving all the way down to Vereeniging in the south, and approximately, might be lying here, about 160 to 180 kilometers of continuous urban settlement, much bigger. Number 7, can we get bigger than that one? The word metropolis. comes from. We use this in South Africa a lot. If we look at, if we break that word into metros, we have the Tshwane Metro, Kuruleni Metro, eThekwini Metro. Those are all bigger metro areas. What you have here on the map is the metropolis of London. So in the United Kingdom, the actual city of London is actually only described as 1 square kilometer. But now it's grown and grown and grown and grown and has joined up with a whole lot of other cities. How does it look? Have a look at the density. This is a Chinese city. Look how close the buildings are. Look at the high-rise buildings. And this is what you're going to be looking at when you study urban settlements in a great detail. It's fascinating as to why they're so tall and what is happening at street level. All kinds of economic, climate, social issues that you will study more in urban settlements. And then, where's it going to stop? Have a look at this word. If you can pronounce it properly, well done. I will try my best. Don't go too fast. Megalopolis. Mega, I think for the streetwise word, mega, big, although I think I'm not up to date in terms of some of the street slang. But Lopolis, see it like Flopolis. These are urban areas that have stretched. Most of them found here in Southeast Asia, couple here in South America, and then I want to show you here in North America, there are megalopolises. The biggest one is this one here that is found in the northeastern coast of the United States of America. There's a city called Boston, I think it's up here, and it stretches all the way down approximately 400 kilometers or more. You will drive and never see an open space. It's concrete, buildings, businesses, houses. Where do we go from there? What's the future? Will the future be a continent covered by urban areas? Will Boston here, Chicago, Florida, San Francisco, Los Angeles, Texas, and all its big cities, will they eventually once join? That's the job for futurists, people who will see or will summarize how our life will be going. So there are 8 different classifications, from the very smallest, the isolated farmstead, to the very biggest, the megalopolis. How do you tell the difference? Size, and only size for this one. There is one proviso. Please be careful. Sometimes size isn't an indicator. You can find very, very big settlements in India, for example, where most people are farmers. The numbers are vast, but there's no secondary and tertiary activities. Or you can find very small settlements where excuse me, the secondary and tertiary activities are at a high standard, like Silicon Valley in California in North America. To end off, just to have a look at some possible exam type questions. What I've taken is 2 questions from past exam papers, not the multiple choice questions, but the lower order questions which come at the beginning of your particular question. Remember, there are 4 of them. You have to choose 3, and this year is the last year that exam will take place in this format. And if we have a look at our screen, we have 2 pictures here, A and B, the Y that I've indicated. What did I ask you earlier? Before you go to the question, start off with what you know. Please, please, please. You often throw away marks in the exams by just ignoring the pictures here or there and trying to answer them on what you've learned or what you've studied. Look at the picture. Place number A on the left-hand side. Describe what you see. Place number B. Describe what you see. Then go to the question. Let's have a look at 2.1. Okay, it says this type of settlement is uniform. Unifunctional. Unifunctional. What does the word uni mean? One. We've got two types of settlement, rural and urban. Rural is one, urban is more than one. So this type of settlement is option A. There is only one function in picture A. It is a primary activity, farming, only one. Question number 2, associated with tertiary activities. If rural is primary and urban is secondary and tertiary, then place number B fits question 2. Question 3, the smallest of these settlement types. Remember, the rural settlements are the smallest. If A is a rural, then that should be the answer for question 2.3. 2.4, this is a pattern question which I'll be dealing with in a lot more detail in the second of the lessons in terms of describing rural settlement patterns. But nuclear means close together, dispersed means far apart, and when you looked at the isolated farmstead, that would be a rural area and it corresponds to picture number A. 2.5, the opposite of a dispersed pattern. I need to do some corrections here, and suppose we can correct this later. The answer for 2.4, the settlements are always nucleated. That is B. We also make some mistakes, and it's often very good just to go back and check. So a nucleated settlement is B. A dispersed settlement is A. An over-concentration, that means too many activities in a small space. That happens in a city, which is picture number B. Metropolis, remember metropolis we spoke about earlier. It was the second largest of our settlements, and that would be settlement number B. And then this word central place is a concept that the urban settlement geography lesson will expand, but a central place here is place number B. So all you would do in the exam is you would write down 2.1a, 2.2b, and so forth. But again, if you can, use the resource to assist you into answering your questions. Right, one more. Let's see how we've done in terms of looking at the sizes of settlements. Picture at the bottom, if we can refer to this one here, it looks like a pyramid. And on that pyramid, let's do our exercise again. What do we know? The word pyramid looks like a triangle, and it has names. Can you see the names? It starts off here at the bottom with a 1, and it talks about an isolated settlement or a farm, and then it goes right up to the top and talks about a primate city or a capital. If you read what the arrow says on the side here, increase in the size. So if you go from the top to the bottom, they get bigger. And here, if you go from that side to the bottom, it says the increasing number of settlements. Here's the tricky part. What are we counting? Here at the top, how many of primary city settlements are there? There's 1, and it possibly has 10 million people or more. The thing that confuses us is, at the bottom, how many settlements? There are 10 million or more farmhouses. But how many people in each farmhouse, or how many families? Probably only 1. So be careful with that proportionality. You'll see question number 1.7 talks about the scientific principle about the size and the number of settlements and their proportionality. Let's have a look at the last 8 questions. Number 1, the isolated farmhouse consists of the isolated farmhouse, probably only a single building. Number 2, the number of settlements, does it increase or decrease as you move up the settlement? Let's have a look at our triangle at the bottom. The number of settlements decreases. Here's the tricky one. Have a look. Bottom one in yellow, 10 million, 3 million, 2 million, 1, 500,000, and so we go on as you go up, and it decreases. But as you move down the settlement, question number 3, the number of people in those settlements decrease. That's the tricky one. That's the tricky one. Take a bit of time. It's almost the obvious answer to what you think it should be. A large city, number 4, we know what that's called. Which one's bigger? Megalopolis, or the floppy one, or a metropolis? And that megalopolis was number 8. Question number 5, do we have an example in a South African situation of one of these? To be honest with you, I think South Africa has metropolises, and the question reads, it's an example of the not included. It's an example of the largest one that's not included. Let me just make sure of that one. Yes, that would be correct. The name is not at the top here. Right, 3 more to go. The only example of a conurbation in South Africa. Things have changed. PWV, old word, but let's help you out with that old word. P stands for Pretoria. W for Witwatersrand. Nice Afrikaans word that you might struggle with the R's. Witwatersrand or rand. It's a nice, if you'd like me to explain it, it's a drainage pattern, white waters ridge. Where is it? In Johannesburg. It basically runs through the Jeppe area. I know Jeppe Boys High School sits on top of that Witwatersrand. And the V for vereniging or vereniging is the bottom part of this metropolis. Durban Pinetown, yes it is. It's Durban and Pinetown that have joined up, but the answer here is PWV. The only thing that might have been a problem is that you wouldn't have understood the PWV. 2 more to go. Question number 7, the relationship between that arrow and this arrow. Can you see the arrow on the left-hand side, the arrow on the right-hand side? As the one goes up, the other one goes down, and that word is indirect. Maybe just to show you what I mean by proportion, indirect proportion. If you look at these 2 arrows, I'll show you what that means. We are looking at that description. Okay, and if you look at that description, the arrows going up and the arrows going down, that is an indirect relation. And here, where they're both doing the same thing, it's a direct relation. And then the last question, the smallest example of a rural settlement in these 2 options is a hamlet. Thank you very much for listening. I hope this has been a great help. It's been a great honor from my side to be asked to help at this time in our country. And I think if we all stand together, if we all stay safe, we'll get through this. So I'd like to say God bless and have a wonderful day. Bye-bye.
Good morning, learners. I'm Madam Maluleke from Kenilworth Secondary School, a geography teacher. I want to do with you the urban settlement. And you can ask yourself that why we have to study this settlement. Not too long we're doing rural settlement. Now we are going to do urban settlement. There are many careers that you can do when you are studying this urban settlement. When you go to university, you can be able to study to be a town planner. It's related to what we are going to do today. And you can be an environmental engineer. So there are many things that you can follow when you go to the university. Okay, let us look at today what is it that we are going to cover in urban settlement. the first thing that we are going to do is we are going to look at urban settlement concepts. There is a very important thing about concept. When you are in geography lessons, you need to take note of concepts. Concepts are very important. When you are looking at concepts, you need to take note of keywords when you are defining your concept. There are keywords that make your definition to be acceptable and to be understandable. So it's very important for you to understand the concepts. Okay, and the next thing that we are going to cover, we are going to look at how site and situation affect urban settlement. And then the next thing we are going to look at classification of urban settlement according to function. And then we will be able to understand what is a function. Okay, and then we are going to look at urban hierarchy. We are going to look at urban hierarchy later at the end of our lessons. Okay, I want us to look at what is urban settlement. You started learning about rural settlement. In rural settlement, when you define it, you indicated that it's predominantly looking at one function. This function is a primary activity where we only focus on farming, fishing, forestry. But when we look at urban settlement, it's more bigger than that. But this urban settlement, it's covering places that are in urban areas. That's what I want to explain to you. Okay, let's check on what is it that we have to look at. What is the difference between a rural settlement and an urban settlement? What is it that differentiates the two? Is the functions that we get in urban settlement and the functions that we get in rural settlement. In rural settlement, we only focus on one type of function, which is primary activities. But in urban settlement, there are more activities that you find there. Okay, and let's look at, to recap on what you have explained, what is a rural settlement. A rural settlement is an area whereby primary activities dominate. And we describe that as what? As unifunctional. Okay, when we look at urban settlement, we are indicating that it's a build-up settlement, like a town, city, and it can be described as what? As having multifunctional, which is what? It focuses mostly on secondary activities, tertiary activities, and quaternary activities. So the most important thing that we need to take note of is that when we look at primary activities, it's only for rural settlement. But when we focus on the secondary activities, tertiary and quaternary, we are looking at the ones that are belonging to the rural urban settlement. Okay, let us look at how does this urban settlement originate. It did not originate where you find that we wake up today, we find that there is a settlement. No, it was originally a rural settlement. When we have a rural settlement, that's where we practice agriculture, we do farming. So people long time ago, they used to do farming. They farm, and then they have enough of this, raw material that they accumulate when they are doing agriculture. So they realize that they are not getting proper income when they are having this raw material. So they come with ideas of, now we have to do something. They started processing those raw material, which means they manufacture to get end products that are more useful than raw material. So they started manufacturing others, they started making clothes, and then now, when they are among themselves, they started interacting with other people, they trade among themselves, and then that's where villages originated. And when they are in that place, they continue trading among themselves, and then we find that there is a town that they have developed, and then later we have a city, later we have metropolis, megalopolis. I will explain that later. So now when we are looking at these places, we still have rural settlement, but we have urban settlement. In this urban settlement now that we are having, the whole world now, we have more than 50% of people who are living in urban settlement. That's the thing that we are going to look at today. Okay, the most important thing, the reason that makes us to have urban settlement is that there is a transition that we have from primary activities to a secondary activities. That is why, just take note of these learners, that I have indicated that originally a rural settlement, it's transformed and just because of the function that are transition. Okay, let's look at a primary activity. A primary activity, now if you start manufacturing raw material, so now we'll be having what? Secondary activities. But if you start doing the services, that's where we are talking about tertiary activities. Okay, let us look at the concept. When I started, I said we are going to explain the concept. And concept, when we explain them, they are having very most important keywords. So when we are defining this concept, you need to take note of the keywords that we find when we are defining this concept. Okay, let us look at the first one. The first one is urbanization. What is urbanization? Okay, the urbanization is the process by which an increasing proportion or percentage, the proportion or percentage of a country's population that are living in urban areas, which means we focus on the percentage of people that are living in urban areas. Okay, when we look at this, these are the keywords. When we define urbanization, take note that every time your definition must have either proportion or percentage, which means that's where you are outlining how's the urbanization. Okay, let us look at the picture. Okay, when we look at this picture, there are many people that are here. I'm just showing you that these are the people, but this is not in percentage. When we are talking about urbanization, we look at the percentage of people who are living in urban areas. Okay, let us move on to the next concept. With these two concepts, I put them in one place because they are related. When I'm explaining them, you'll be able to take note of something. Let us look at urban growth. Urban growth, when we look at urban growth, we talk about a natural increase in the number of people living in urban areas. Here we look at there is an increase in the number of people living in urban areas. So many people are living in urban areas. So here we talk about the population that we find in urban areas. Okay, that's where we are talking about urban growth. And then the next concept is urban expansion. With urban expansion, we look at physical growth. Okay, that is why I put these two concepts together. When we look at urban growth and we look at urban expansion, the more we have people in the urban areas, that will force the people who are developing the city to build more structures. When we are building more structures, which means we want to accommodate people who are in these areas. So that will make a physical structure of the city to grow up. So that is why we are indicating that the city will grow. Look at this picture here. It's a picture that it's showing us how the urban settlement look like. So we can't see people in this place, but we have many people who are in this place. And then that makes this city to grow. They are building more structures in order for us to be able to understand that now there is a physical growth of the structure. There are more structures that are built to accommodate the number of people that we find in urban areas. Okay, let us move on to the next slide. Okay, we have the next concept, which is urban sprawl. When we talk about urban sprawl, here you need to take note of something. Okay, this city is growing, but it's grow haphazardly. It's not following the plan that the planners, they have planned that it is going to look like this one. Okay, when we define it, let us look at urban sprawl. Urban sprawl is unplanned or haphazard expansion of low-density residential areas development. Okay, here we find that people, they just come and build anyhow. Most of these people, they build next to the roads so that they can be easily accessing the transport. But the most important thing is they don't follow the plan of the city. They don't follow the plan that the city was supposed to look like. They just come and build anyhow. So you find that it's growing any direction instead of following the plan that it was supposed to look like. Okay, let us look at the picture. Okay, when you look at this picture, it's just showing you a spreading where people are building. So you find that these people, they come and build just because they check on the environment. What is it that suits us? We want to be quick when we go to work. They just come and build next to the road. And then they start deforming the original plan of the city. That is why we talk about urban sprawl. Okay, let us look at the next concept. The next concept, I put them together. The first one is the rate of urbanization. Okay, when we look at the rate of urbanization, we need to look, we are focusing on the speed. What is the speed that the urbanization is occurring in urban areas? So we look at how fast urbanization takes place. Okay, so we look at the speed, how the development, which means the transformation of rural areas to become an urban areas where we have got more functions. So, and then the second concept, we look at level of urbanization. With level of urbanization, we look at the percentage of total population living in urban areas at a given time. Okay, let me explain to you on this one. When we look at the first one, we said it's the rate of urbanization, how fast urbanization takes place. But when we look at level of urbanization, which means we look at the percentage of total population living in urban areas at a given time, which means we can be able to say, I said when I started that we've got more than 50% of people who are living in urban areas. So when we look at people who are living in urban areas, now we look at the rate. We can project and say in 2025, we'll be having 55% of people who are living in urban areas. Okay, let us look at the diagram, the graph that I given you here. Okay, I brought this graph grade 12 because in the exam, they sometimes ask you to interpret the graph. So you must learn the skills of interpreting the graph. The graph that you can get in the exam, it's a line graph. You can get a line graph. You can get a bar graph. You can get a pie chart. Okay, let us look at the graph that I have here. Okay, the most important thing that you need to take note of when you are looking at the graph, when you are interpreting the graph, make sure that you study everything that is provided for you. You don't just rush to go to give answers. Please study everything that you need to understand. You need to look at everything that is in the graph. Okay, the first thing, you need to look at the heading of the graph. It's very important, grade 12. When you are looking at the heading of the graph, it tells you that this graph is about what. So when you approach the graph, you need to be able to understand that the graph that I have in front of me, it's having the heading. What is the name of the heading of this graph? It's saying global population growth and urbanization expected trend between 1950 and 2040. So which means we look at the graph, there are things that we need to take note of. Okay, on your x-axis, you do have years that are being indicated there. Okay, when you check the years, the first year they indicated 1950, but it's not the original year. You have from zero from this side, you have the years that were there before. So in between, there's a space where they did not put the years. So you need to calculate those years if they're asking you something about that. Okay, so it's very important for you to check that, okay, they have given us years in the x-axis where you have to look at the first year, the second year, the third year. It goes in relation to what is being indicated up here. Okay, let us look at on the left-hand side of the screen. We have the total population, and then it's given in a figure of billions. So when you are studying the graph, you need to take note of, this side they have said total population in billions, which means the number that appear this side on your y-axis, which means they are representing total number of people who are in the whole world that are living in urbanization. Okay, when we look at this total population in billions, so you check between 0 to 2 and from 2 to 4. So in between, which means we've got 0, 1 billion, 2 billion, 3 billion, and then you go upwards. And then when you go on the right-hand side of the screen, okay, let us be able to look at this one. They indicated urbanization in percentage. Okay, now they are showing us that urbanization is taking place worldwide. Okay, but there are different percentage that these people are growing to become urbanized countries. Okay, when we look at here, they give us 0 to 100. So in between, there are numbers too. You know that before 20, there are numbers that 10, 15, up until to 20. And then inside, we do have key symbols. These key symbols are very important when we are interpreting the graph. You need to take note of these symbols. Okay, in the exam, you are not going to get these colors. You are going to get black and white. Okay, but the most important thing, you must be able to know that this one, the green part that is here, it's indicating, it's showing us the total population that we find in the whole world. And then with the other one, it's indicating the reddish one, it's showing us more developed regions. With more developed regions, that's where we talk about more economical developed countries. Okay, and then with the other one, it's purple, it's less developed regions. So these are the LEDs countries. Okay, when we look at this, you look at this symbol of the world. It's represented here. It's been drawn here. So when they ask you in the exam, they can be able to ask you, what is the total percentage of people who are living in more developed regions? Grade 12, the thing that you need to come and check, you will be able to come and check where they've indicated in percentage. And then if you are going to answer the question in a perfect way, just look at and you understand the question. Let's take they've given you a question that is asking, what is the number of people according to the graph? According to the graph, what is the percentage of people who are living in urban areas in more developed countries? In which year? 1980. Okay, so you'll come and look at where is 1980, and then you look at that graph of more developed countries. You look at this figure, and then you check there. Okay, when you are checking here, which means it's showing you that they are asking you about the percentage. So you will follow that in that year, it was not on top of the line of 80, which means it's plus minus 78% of people who were living there in 1980. Okay, so the thing that you need to take note of, but when you are looking at this, make sure that you know how to estimate in a correct position in order for you to get a proper answer. Okay, another thing, if they're asking you about the total population who are living in less developed countries, which means you have to come and look at the purple one, and then you check, and then you'll be able to answer those questions. So what I'm showing you is that when you are interpreting a graph, you need to take note of certain things, that you use the key symbols. These key symbols are the ones that are giving you, in reality, what is happening in the whole world in terms of urbanization in percentage and total population in the whole world. Okay, we can move on to the next slide. Okay, here we are talking about the characteristics that determine classification of settlement. When we look at the settlement, it's being characterized, it's having things that are determining it, that this is an urban settlement, this is a rural settlement. So an urban settlement is classified according to, we have the pattern, we have the size, and we have function. So the pattern of urban settlement, it's nucleated. Okay, and then the size of the urban settlement, we do have different sizes of this urban settlement. When we are busy doing the rural settlement, you did check that they've been classified according to size, according to pattern, according to function, but they differ. In rural settlement, you did indicate that we do have isolated farmstead where you find that a building is here and a building is that side. But when we talk about urban settlement, we talk about things that are over-concentrated in one place. We talk about many functions. We talk about many buildings that we found in this place. So that is why we are talking about the pattern of urban settlement is nucleated. When we come to the size we do have the type of this settlement. They are not of the same size. We do have the town. The town is the smallest size of the settlement in urban areas. In rural settlement, you did talk about isolated farmstead. You spoke about hamlet. You spoke about village. But here for urban settlement, we have the town, which is the smallest of urban settlement. And we do have the city, we do have metropolis, we do have conurbation, and we have megalopolis. Okay, let me show you in the form of this pyramid. Okay, I want you to take note of drawing or illustrating drawings when you are studying. It's very important, but because it makes you to understand what you are studying. Okay, when we look at this pyramid here, I just want to show you where do we find this, how do we classify it according to its size. Okay, at the bottom, you have 3 settlements. You have isolated farmstead, you have hamlet, and then you have village. These ones are being classified, but it's for rural settlement. You must remember that we are doing urban settlement. So for urban settlement, we start with the what? With the town. We start with the town, and then we have the city, we have metropolis, we have conurbation, and we do have megalopolis. We do have megalopolis. So when we are looking at the classification of settlement in urban areas according to size, we are looking at town, city, metropolis, conurbation, then megalopolis. Okay, we'll look at it later. I'll come back to the diagram. Okay, let's come to the next one. There is a function. Remember, we said urban settlement is being characterized of multifunctional. What do we mean by multifunctional? We're talking about it has many functions. Many functions such as what? Secondary activities, tertiary activities, and quaternary activities, which means they focus in more activities than in rural settlement. So when we classify these ones, okay, the function that we get here, they are not going to be the same as the one that we get in the city. They are not going to be the same as the one that we get in the metropolis and even in the megalopolis. So we classify them according to pattern, size, and function. So the function differs. We'll outline that later. What do we mean by function differing? Okay, let's look at, I have defined this concept for you. What is a town? A town is a densely populated urban area. I gave an example of Harrismith. It's not only Harrismith. There are many places that are having the characteristics of densely populated, which means a town is bigger than village. It's having more population than village. Okay, and then the next one we have a city. A city is a large town where many people live and work. I gave an example of East London and Bloemfontein. So when we look at this one, the population that are staying in this place is smaller than this one that are staying here. So we have got more population here than the one that we have in a town. Okay, and we have the next one, which is metropolis, a main city in a region which is surrounded by dependent towns like Cape Town, Durban, and Port Elizabeth. That's the metropolis. And then we do have conurbation. When we talk about conurbation, that's where we find that towns and cities, they are jointed together to give us one thing. So that is why we talk about conurbation. We do have an example of that here in in Johannesburg, where we have Witwatersrand, Pretoria. Witwatersrand, it's an area where it's including what? It's covering Pretoria, Johannesburg, and Boksburg, which means we have got cities and towns that are jointed together. That is why we are talking about conurbation. But with megalopolis, we don't have the example of that here in South Africa. Okay, what is megalopolis? Megalopolis is a very big urban complex formed when a number of conurbation join together. Okay, so this one is made up of many conurbation jointed together. That's where we get megalopolis. And we have an example that we find in the United States where we have got Boston, New York, and Washington. And we have the abbreviation, the acronym that is abbreviating that, which is BONIWASH, which is Boston, New York, and Washington. Okay, the next thing that we need to do, we were explaining the concept that we find in urban areas. Now we are going to start with how site and situation affect location of an urban settlement. You did site and situation for rural settlement. Let us look at what are the things that they look at if they want to build an urban settlement in terms of site. But first, we need to understand, what is a site? A site is a place on the land where a settlement is built. Okay, so what are the things that people who want to build an urban settlement, they will look at? Okay, they will look at various things, but these things must be physical factors, not exactly with the one that we look at in rural settlement, but most of them, they are the same. Okay, but we do have reasons, because here now we're no longer focusing on farming, we focus on many functions. So let us look at these physical factors. Physical factor, availability of water. Okay, yes, water is needed. Even in rural areas, we need water in order for us to start building. In order for us to build a settlement, we need availability of water, we need drainage, soil. Most important thing here, yes, we can do farming in urban areas, but most important thing about the soil in urban areas, we look at is water, if we have water in this area, is this soil suitable to allow water to infiltrate, to seep in, so that the area cannot be flooded? So they check looking at that if this soil is going to drain water, so that the area is not going to be flooded when we have built this. Okay, and then the next one is underlying rock structures, where we look at the rocks that are underneath are not going to have an impact on our structures. Remember, the structures that are built in urban areas are not the same with the ones that are being built in rural settlement. Here, there are very big structures. And remember, these structures, they can be on top of each other, where you find that we are having flats. So they have to check underlying rock structures. And they have to check that in these areas, we don't have even sinkholes, that when we have built a settlement, and then you find that it's sinking down. Okay, or even fault lines, where we find that we do have fault lines underneath that will cause our building to crack. Okay, another physical factor, we look at relief. Grade 12, when we talk about relief, we're talking about the slopes. How high is the place, or how flat is the place? So people who are constructing or building urban settlement, they will look at the relief. Most of the preferable slopes that are good for building are the flat ones, are the gentle ones. So when we are looking at the flat ones, why the flat ones? They are very cheap in order for you to build there. But it's very nice even to build in a steeper slope. Other people, they can do that, but it's very expensive. So people prefer flat land to build on because it's cheap. Okay, let's look at the next one. The next one is availability of resources, where we need building material. Or in that area, do we have building material where we can be able to get these resources that we can use to build our settlement? Okay, and then the last one is aspect of a slope. It's very important for you to understand what is an aspect. Aspect, we're talking about the direction which the slope faces. So us who are in southern hemisphere, when we are looking at the slope that we are facing north, which means we'll have direct sun's rays. So they check looking at that, which slope is suitable for us so that if it's winter, we are going to be able to receive sun's rays that is not going to be very cold. So these are the physical factors that we must look at when we are looking at the site to build urban settlement. Let us look at situation. These are the concepts that you have already understand when we are explaining to you about rural settlement. And the situation that we look at when we are doing urban settlement, situation refer to a location of a settlement in relation to the surrounding, which means now we look at, you are locating this settlement in a place that is already developed. Things are already there. Why? What is it that you are looking at? You are looking at in terms of transportation, okay, transport and trade. And then is this place accessible? Are you going to be able to move from point A to point B? So that is why I gave you this diagram that is showing you the roads, that it's easily accessible. That's the situation. How does the situation differ with site? Site, we look at physical factors. But when we look at situation, now we are looking at things that are already existing. Okay, let us look at function. What is the function? When I started, I said we are looking at urban settlement. Okay, the function of rural settlement, we just spoke that are primary activities. Okay, when we look at the function, the purpose or original reason for the establishment of the settlement, which means this function that we have in the area, let's take we are having primary activities. If that primary activities, now we start manufacturing, manufacturing goods, which means we process raw material. The function will change from what? Primary activities to secondary activities. So that is why I said the purpose of original reason for the establishment of settlement, which means function is the core that will make us that to see that we are developing because there is a change from that original function. Okay, let us look at the next point that I did indicate. Urban settlement are multifunctional. They have many functions. Which functions are we talking about? We are talking about secondary activities, which is what? What do we do in secondary? We are doing what? Manufacturing and industries. That's where we have industries that we are processing and manufacturing these goods. Okay, and then we do have the tertiary activities where we have services, okay, like medical, banking, retail, and then we do have the last one, which is quaternary, where we have got the analysis, they deal with research. Okay, we'll talk more about this type of activities in detail when we are doing economic geography. Okay, let us move on to the next point. Okay, here we are talking about the classification of settlement according to function. So we classify settlement according to function. Okay, there are three categories of this classification of settlement. So we do have the central place, we do have trade and transport towns, we have specialized towns. Okay, when we look at the classification of urban settlement according to function, which means each one, they do have functions that are taking place in those areas. Let us look at the first one. We are talking about central place. What are the central place? I did indicate that the pillars where we are going to look at the first one. The urban settlement is being classified according to function. The first one is central place town. What is a central place town? Okay, with this one, you find that we do have an urban area, which is a central place here. Let's take we are having a town here. And then we do have rural areas that are surrounding this area. These people will come and be serviced in this place and get services in this place. So this is a central place. So if you are having this as a central place, okay, these people who are surrounding this area, people in urban and rural areas, they will come and buy in this place. That is why I said its main function is provision of variety of services surrounding rural settlement, which means you look at this function that is in the center, and people who are surrounding this area, they will come and get services in this area. Okay, and then the second one is trade and transport towns. This town, they develop just because of what? There are activities that are being done in that place. For these ones, they are developing just because of the transportation that is taking place. So this transportation is taking place in different ways. Okay, we have the trade and transport roads, sorry. Okay, usually along the transport roads, we are going to get that we do have break of bulk points. With break of bulk points, grade 12, this is what I'm talking about. We talk about, this area developed just because there was a break of bulk point. What do I mean by break of bulk points? Which means there is a transportation of goods. When they transport goods, you'll find that the goods are coming with what? With a ship, and then come and delivered by the harbor. From the harbor, it's no longer going to use ship to move to another area, but now it's changing the mode of transport. So now when we talk about break of bulk points, which means there's a change of mode of transport. We have the ship that comes with the cargo and delivered it by the harbor, and from the harbor, the truck takes the goods that have been delivered by the harbor and transport it to the market. That is why in this place here, I have indicated we do have, this is an example of sea, and then we do have the ship that are carrying goods and then transport it and come and deliver it here. When they deliver it here, you see these are the trucks that are taking the stuff from this place and transport it to different markets. So this one we call